can see on the screen, I am very excited to move forward with the series. We are going to start with agents. Okay, so far in that AWS AI series that I was doing, we've built intelligent systems using LLMs, RAG, and a lot of cloud AI services that was there in AWS. Now those services I picked from AWS. It doesn't mean that you have to stick to AWS itself. There are a lot of other platforms which provide the same kind of services. The concept is same. You can go ahead and apply those concepts in any kind of platforms that you want. Okay, so I just wanted to get that out of the way. Okay, so now we move to the next evolution of AI engineering or AI development or LLMs and whatnot, right? Agents, systems that don't just respond, they plan, they decide, they act everything on their own, right? They have their own brain, they will plan out tasks, they can do anything that you want them to do, basically, not just reply to prompts and give you an output. So that is what agents are. So the agenda of this particular video is pretty simple. You are going to see what is an AI agent, okay, what are the core components of an AI agent, chatbots versus agent, reactive versus agentic flow, agent architecture we are going to see, and the roadmap, what we are going to do from now on, towards the future in the series, right? And I'm very excited, and I'm going to be very, frequent in uploading more and more videos, because I am absolutely interested in this AI plus cloud computing thing, okay, because it just makes it so interesting, and nowadays it's the crux of getting the jobs. Yeah, it's true. If you are centered yourself as a developer who uses AI tools, is up to date with all the AI concepts that are there, in the market, you position yourself in the top 1% of the people who can use AI tools effectively, and they are the people who would probably get the job that everyone is aspiring for, right? So keep yourself up to date, and obviously if you follow my videos, you're going to be updated quite frequently. Okay, what is an AI agent? Basically a system that uses an LLM as a reasoning engine. It can perceive input, whatever you want to give. It can plan actions, right? It can use a lot of tools. It can also update memory. It can interact with a lot of external sources, everything on its own, right? It's like a functioning brain. It has a brain like the LLM engine. It has hands and legs, right, which are the tools, right? It has an organized way of approaching to things like a human does, basically, right? And it will finally give you something that it does, right, as an output. For example, booking a flight. Now booking a flight is a very complicated process. If you see it from a human perspective, right, it is a lot. Basically, it's not just go to a website and book a flight from A to B. We check for cheap flights, we search tons of websites, we search the web like crazy until we find the cheapest thing possible. We see the dates, where, for example, you're traveling to some country like Japan, right? You see which week of which month you would get flights for cheap, or the time when it is less touristy, because you want to enjoy every aspect of Japan. These are all the things that you do in a manual manner, but you can delegate all these things to an agent. It will do everything that you want, and then finally it will give you an output, and the output in this case is basically booking the tickets, right? Don't worry, it is not just theory. We are just starting with small concepts of agents right now. Obviously in the following videos we are going to build an agent, obviously a code based agent, using Pydantic AI, and we're going to deploy it in AWS. We are also going to see the A2A protocol and all those things. Don't worry about these technical jargons. Let's start from like a layman's perspective and understand what an agent is, and then we can dig deeper into the demos. Okay, so as you can see on the screen, it can interact with data, tools, and systems to achieve a goal. Obviously, there's a goal that I told you, right? It's output, and it just goes beyond the starting question and answer thing that you do on a conversational LLM like ChatGPT, right? Obviously, ChatGPT now also gives you the freedom to use agents as well. If you go to ChatGPT, and there is this one small icon over there that you see called an agent. For example, you want to create a PowerPoint presentation, right? You can select the agent mode, and then you can ask ChatGPT to create a PowerPoint presentation. That is also a use case of an agent as well, right? If you want me to create a video on that as well, you can just put it down in the comments. But the series particularly focuses on code based agents. Basically, from a developer's perspective, that is very, very important. Okay, now chatbots versus agents, it's pretty simple. For example, what do you ask in ChatGPT, right? Like, for example, you ask, book me the cheapest flight to Tokyo next month and add it to my calendar. So ChatGPT will not do these things. Instead, it will suggest you the steps how you can do it, and it cannot actually execute anything, right? It's a conversational thing, right? It doesn't have ability to work around with tools. I'm talking about the normal ChatGPT interface, guys. Don't confuse it with the agent mode or other modes of ChatGPT, right? Those are modes. I'm just talking about the normal conversational flow that you get in ChatGPT, in Gemini, and all those things. It's just a conversational. It will suggest you the steps, but it will not execute anything. It doesn't have autonomous loop just means that agent does something, it finds a better solution, it will restart the particular approach again and again. That's an intelligent process, right? So you can find those things in agents. Another good example of agents is a coding agent that we saw in Amazon Q, right? Where it generated code in the agentic mode, right? The agent is writing the code. Or Codex is also a very good example. Claude code, Cline, all of these things are very good examples of coding agents, right? And as I've already explained, agents, it pursue goals autonomously, it can plan tasks, act, analyze, and adjust accordingly. And the best things about it can communicate with other agents like humans. Like, I am a human, I communicate with another human, and our way of communication is basically through speech. But agents, they communicate through a specific protocol known as A2A protocol, which is agent to agent protocol. Okay, uh, for tools and all also, you can create the tools in the same environment. I'm going to show you when I'm going to show the demo in the following videos. I'm also going to cover MCP as well, right? That is also very, very important. As I've told, don't worry about the technical jargons. Let's stick to the basics for now. We're going to cover one by one as time goes. So agent architecture is pretty simple, right? So we have a user goal over here. First of all, you have to give the goal and input, right? Basically, what do you want from the agent? What do you want the agent to do? Then comes the perception layer. So the LLM comes into the picture now. I'm going to show you how you can integrate LLM into an agent in the next video perhaps. For now, just understand that LLM is the brain of your agent, right? So goal and input is what you tell. For example, there is a person over there, you're telling, okay, you go and do this thing. That is your goal and input. So the brain of that person, in this case the agent, will perceive what goal and input the user has told me to do. Then accordingly, the agent will plan intelligently what to do. Obviously, when you give a task to someone, they plan it accordingly, right? How to do it. They just don't go and randomly do it. Similarly, the agent will also plan it. I'm going to show you how it does basically, right? Obviously, it's an intelligent, it involves use the LLM. We're going to see that. Then accordingly, it will use specific tools. For example, you have created an agent to book flights, cheap flights, right? The first thing is the agent will do is perceive your input. It will take the dates where you need the flight, the source and the destination, right? All of these details it will take, and it will plan what to do, the steps. And the first step, it has identified that, for example, I need to search for a week in the month of April where the flights are cheap. For that you have created a tool known as get cheap flights, for example, right? And it will intelligently detect that, okay, at this point of time, I need to figure out that I need to find the cheapest flights. So it will use that tool intelligently. You don't have to specify in the code that, you don't have to do a method call for that tool also. You can just specify in a normal prompt, use this tool whenever you feel it's necessary. So it will automatically register that tool, right? And it will use accordingly. So that is the tool usage, right? Tools are nothing but some kind of planned actions that the agent will do to achieve some part of the goal. And after all the tools get executed, finally after completing the goal, it will do the memory update and it will return you a result that, okay, this is the flights that have been booked from this date to this date, and these are the most cheapest flights that I found and it has been booked, something like that. So agents repeatedly cycle through perception, planning, tool use and memory updates. Obviously it will complete, unless it is finding you the best solution or whatever the intended goal is, it will cycle through this process again and again until the outcome is reached, a satisfactory outcome is reached. I hope that is making sense, guys. If you have any questions, put it down in the chat. Okay. So the core components of an agent is pretty simple. As I've discussed, the LLM reasoning engine, for example, in this case, Bedrock or Olama model or Gemini model, right? Text model, whatever model you are using, that will be considered as the brain of the particular agent, right? Obviously. Tools. It can be a function, it can be API calls, it can be MCP server, right? So that will be basically, it will enable the agent to act in the world, to do something basically. As I told you, right, a tool is nothing but a planned action that the agent will perform to achieve something that you have specified in the goal. And if you create multiple tools to achieve that specific goal, it will execute all of the tools at the required time intelligently and then give you the desired outcome. Memory. You can specify the memory, how much the agent can use the memory in case of input output tokens and all of those things. Across the agent runs, it can persist that memory as well, and it can learn from it and perform better and better as you give more inputs. Planner. It just breaks down the goals into steps and orders the tasks that needs to be done. And this is known as the agent loop. It will observe the results and refine the plan, as I've told you, right? Until you get the satisfactory result, it will improve itself, right? That is why it's an intelligent thing. Otherwise, there is no difference between an agent and a standard microservice. The intelligent or the reasoning part, all this planning, all this intelligent works and all those things are the difference between a normal microservice and an agent, guys. I hope that is making sense. And as we move forward in the series and do more and more demos, right, you would understand better what an agent particularly does. As we have already studied about a chatbot, right, like conversational interface and basically an agent. The difference, there are chatbots and microservices that are already there since decades. So basically this is a reactive kind of a solution, right? When you are talking about chatbots, you give a user input, the chatbot will process the input and it will give you a response, right? So it is single turn, it has no memory. But when you come about LLM conversational chatbots like Chatgpt and all, obviously it will have a memory that okay, this is what the context it will maintain. But if you talk about older chatbots, right, where it was like rule based chatbots that we were using previously, right, that was kind of a reactive kind of thing. There were some rules defined and based on that it will give you a response. And even though we have Chatgpt, there are certain limitations that it cannot perform a lot of actions. But when it comes to agents, it will as we have studied, it will be planning, iterating, using the tools, uh, finding out more solutions in an agent loop, iteratively, recursively, until you are getting a proper solution like a particular human, right? So that is the difference. The more intelligent you make a microservice, the more agentic it becomes, in simpler terms, right? I hope that is making sense. Okay, some applications that you can use, using agents. Purchase order processing. Basically, you have a requirement here. You need to extract data from PDFs, and match customers and product info, eliminating the manual entry that they do, right? Executive assistants schedule meetings, queries, calendars, directories, send email confirmations, or basically you can also create an agent, for example, who would take minutes of meeting, right? Minutes of meeting is a very hectic task nowadays. People have to remember everything and then create a summary of the meeting. You can create an agent which can basically do that. Automatic reporting of financial data, it will build the charts, everything. If you there can be a A2A call or something like that which will invoke the agent, and then it will automatically report or make charts and all those things automatically, right? Research or analysis also, you can perform some kind of research, multi-step searches, summarize your findings, refine the results. All of this you can do using an agent as well. Okay, this is a series roadmap that I have thought about it. We are basically in the first phase of agent architecture. We're going to see some planning techniques. We're going to talk about tools and function calls. Obviously, these are going to be hands-on as well. I'm going to show you hands-on creation of an agent very soon in the next video, right? It's going to be amazing. So just stay tuned. Okay, just have a little bit of patience because the basics are also important, right? Multi-agent systems, you're going to see autonomous loops, real world project. Obviously, what I'm planning to do from next video is I'm going to pick up a use case, and I've also thought about the use case. I'm going to tell about it right now. We're going to create an agent which is going to create a series of tickets. If you are a developer, you would know that in Jira we create defects based on whatever the customer tells us a problem. The particular person understands the problem and creates a defect, right? For example, P1 defect or P2 defect, like based on the severity. So what we will do is we're going to create an agent. Basically, we're going to try to mimic that thing, right? You can give a goal or an input, like for example the customer's query or the complaint, and based on that the agent will understand, okay, this is the severity of that particular problem. It will call various tools to notify people. First of all, create a particular ticket somewhere, that can be another tool, and whatever and whatnot, right? So I'm thinking about this use case, and I'm going to do that in particular this series, so that you get a hands-on experience of creating an agent. Obviously, we're going to also deploy it on AWS. We're going to see a bunch of services being used at once, and it is going to be a lot of fun. So stay tuned, guys. Okay, so in conclusion, I want to say agents go beyond chatbots. They plan, act, learn, and then adapt accordingly. So let's begin this AI agentic thing, guys. It is going to be amazing. We are going to see how we can create a simple code based agent using Pydantic AI, and I'm going to show you in action how A2A protocol works, and it's going to be very amazing. Now, from here on, from this particular video, we are going to build our agent to have a lot of different capabilities. Okay, we are just starting small because I don't want to overwhelm you guys in just one video, right? Just think of it like a project, and in every video we are going to keep building on it, right? And we're going to cover a lot of different concepts while we are building on the particular agent. Okay, so the idea behind the agent, what the agent will ultimately do, is pretty simple. Okay, so my agent is something like a consultant agent. Okay, like think of this agent as someone who is working in a company who is an expert in in handling customer queries or something like that. So what happens in customer queries is that your consultant will receive a particular customer query or a complaint, right? And then there are different severity levels associated with a particular query. I mean, it can be P1, P2, S1, S2, whatever your company's naming convention is. For now I'm keeping it P1, P2, P3 and P4, right? Now what will the particular agent do is basically it will accept that particular query or the the complaint. It will assign a severity level and it will kind of create a ticket or a report, right? It will assign, for example, P1, it will create the report. Then it will use various tools. For example, there will be one tool to store this particular incident, whatever happened in DynamoDB. As we are doing everything in AWS, we're going to keep using that, but your tool can do anything. Basically, you can create a Jira tool, which will create the ticket in Jira itself. That's just an idea, but as we are doing it in AWS ecosystem and I want to keep the cost as minimum as possible, we are going to follow this. There will be one more tool, for example, which will trigger a SNS email notification to the stakeholders that okay, this particular, so there are various teams, right, for which the product belongs to, for example, and basically that tool will trigger an SNS notification to the particular, I mean the email notification to the particular team or the particular stakeholder or the product owner, whatever. There might be one more tool. For example, I'm going to create 2 or 3 tools here, and that will be creating a for example, I don't know what it can do. It can create a an audit trail or something for the particular incident. 2 or 3 tools we are going to create for this particular incident, and this is how the agent will work. I want to show you that it's not just a microservice. The agent, basically, it is intelligent. That is how the agent differs from a normal microservice. You have to make it intelligent by the use of your LLM model and your tools. Okay, so that is the idea behind the particular demo. Obviously we're going to build it across multiple videos, and once I'm done with the videos, maybe I will just put it all together and upload another video which will contain the entire agentic series in one video. You can follow along with me while I'm doing this. It's up to you what you want to do. Okay, so this is what the idea behind is, and in this particular video what we are going to do is we're going to start simple. Okay, we are going to create an agent. Okay, and so this we are going to keep it simple for this video, right? So we are going to create a simple agent, right? And we're going to use a model in that agent, right? For example, Nova Lite. This is Amazon's AWS model, and what we are going to do is we're going to accept a incoming complaint. We're going to assign it a severity level, for example P1 and P2, and then we're going to just return it back as a response, return response. That's it. That's we are going to do as a first step. Let's not make it overly complicated with tools and all. Just in the first video, we are going to build on it, as I'm telling. So this is all we are going to do in this particular video. We're going to accept the complaint. I mean, the agent will accept the complaint or the customer query, and then it will assign a severity level, for example P1 to P4, and then it will return the response accordingly in a structured manner. Okay, I hope I'm making sense, guys. Okay, so before we start actually looking into the particular agent, there are the few more seconds I want to take. First, I want to talk about the A2A protocol. A2A protocol. A2A protocol is nothing but agent to agent protocol. Like we have REST API or API, right, as a protocol. So what is a API basically? API is nothing but a contract, between systems. How they will communicate with each other. So basically contracts or this kind of protocols exist so that one system doesn't break the communication with another system, right? For example, there is one microservice who is using SOAP, for example, SOAP based communication. One is using API based communication. Do you know, for them to communicate with each other, it is very difficult because they are using both different kind of contracts or different kind of protocols. If they are communicating using the same kind of protocol, it will be much easier for the client to communicate with the server. But here we are having agents, right? And for agents also, they have defined a particular contract known as A2A protocol, right? A2A protocol. It's like how will you communicate with another agent? It is nothing but A2 is nothing but HTTP, sorry, not HTTP. It is JSON RPC over HTTP. Just a minute, I'm not able to select JSON RPC over HTTP. Nothing but the body that you will send. We're going to see that in a minute. The body that you're going to send as a payload to a particular agent, right? It will be like a JSON RPC message, and you're going to send it over HTTP. So nothing like A2A protocol is like you're going to create a tunnel and send something inside the tunnel. It's not like that. It's obviously over the application layer only you're going to send the data, right? In this case, the API layer, it's just HTTP. HTTP, you're going to send JSON RPC over HTTP. That's it. Nothing more than that. Okay. This is one thing I wanted to discuss because I'm going to send a payload to the agent in this particular demo. So you have to understand how that works. Another thing that I want to understand is how you would know, identify or details about the agent. I want to talk something about the slash dot agent card dot JSON. So after you create an agent, automatically they will serve you one endpoint known as the agent card endpoint. Okay. Now the agent card is nothing but the identity of an agent. Okay. Now, for example, you have a business card. When you give the business card to a person, you are providing some services. Think of it, the agent, like that only. So basically, you give that card to a person. The person will know who you are, what you do. Okay, so who you are, what you do. That's all they'll be able to know, right? So when you call this particular endpoint dot agent card dot JSON, it will serve you some metadata which will give you what the agent is capable of doing. Simple as that. It's the business card of the agent. Okay, I'll show you this in action. Don't worry. I'll call this endpoint for you guys and show you how this endpoint also works. Okay, so this is enough information. I don't want to bore you guys with more and more, theory. So let's go and see how we can create the agent. So I have created the agent using Python and Pydantic AI. You can create it in Java as well, but Pydantic AI and Python supports something known as a fast A2A protocol. Fast A2A. If you have worked with fast API in Python, you would know what fast A2A is. Fast A2A is just or fast API. This is specific to Python itself. Okay, so it is nothing but fancy words. It just means that you can do asynchronous communication with those particular agents and microservices if you are creating in Python. If you want, you can also create synchronous agents as well, but asynchronous, you'll get the response much faster. Nothing but it's pretty simple to understand. For example, you have created a fast API or a fast A2A agent. So when you call the agent for something to do, right? I mean, the agent will process something, right? So instead of keeping you waiting for a long time until the agent finishes the processing, it will return you a response immediately. Okay, with a task ID. Okay, with a task ID, it will return you immediately one response. Okay, now the processing will happen in the background. Okay, but you will have the task ID. Now you will take the task ID of that particular call, and then you would poll to the agent, right, for the status of that particular task, right? You will poll the status of the particular task with the agent. Then once the agent finishes processing, it will either give you a success or a failure response with your required response that you want. So that is the fast A2A thing that is happening, which is nothing but asynchronous communication, okay, or an asynchronous server. I hope that is making sense. Okay, so Pydantic AI supports that. Pydantic, just let me write it down over here. Pydantic AI. Okay, this is a framework that you can use to create code-based agents in Python. Okay, now I'll just share with you this Pydantic AI documentation. I just followed it. It's pretty simple. There are some examples as well, or you can use any kind of coding agent as well to generate. Just give it the if you have Codex or Amazon Q, like I have, you can just give the reference of Pydantic AI and you can ask for specific snippets of code. It will give you those code back and you can just use it in your particular file. Okay, so that is about the introduction about this thing. Now let's see. I have already written the code. I don't want to waste time in writing the code because you can generate the code anyways nowadays, right? It's very stupid to show you line by line code nowadays. You just have to check the code. That's it. I'm going to explain the code. Obviously, you need to understand what code is being written. Otherwise, you are gone, right? So this is the main.py file, and the main thing that you need to understand is this is the description, classify an incident severity P1 to P4 using Pydantic AI plus Bedrock. Okay, now this is the main function. Okay, it will parse the arguments that is coming and then it will build the agent. Okay, now let's go into this build agent method over here. Now here if you see, this is the agent over here. Okay, okay, so if I remember in my previous demos, I had used Bedrock models. Okay, and here also I'm going to use a very basic model of Bedrock to basically we need an LLM also, right, to process whatever is coming and to return the response. At least for this demo, it is very essential because we are doing not much. We are just taking the user complaint, processing it, giving it a severity level, and then returning the response back. So we need the processing power of a LLM. So I'm using Amazon Nova Lite V1. It is a very light LLM. Okay, don't expect it to be processing millions of tokens or something. For demo purposes, you can use it. You don't have to create any kind of a profile, Bedrock profile or something. You can directly grab it, the product ID of this thing, and you can use it. How to get the product ID? It's pretty simple. You can go to model catalog. Oh, I have to sign in again. You see, in the model catalog, you can just search for any model. We have already seen this. I just search for Nova Lite, for example, and you can just go over here and you can get it the model ID from here, and you can just paste it. And also you need to log in as you have to do AWS configure in your CLI, and you have to provide your access ID and token over here, and you already know how to do that. I have already explained it. You can search it. You can check out my videos how to do AWS configure and log in into the CLI. It is pretty simple. You can also find it over the internet as well. Or if you are using some kind of a model which is not present in Bedrock, for example, that is also possible. For example, you are using any GPT model, right? You can use the client ID and secret. You can keep it in the environment variables. You can export it and you can use the model if you're using something outside of Bedrock. It is possible. You can use a Chatgpt model API. They provide a lot more than just the Chatgpt interface. Okay, so it's pretty simple. Let's understand this thing. So we have severity instruction. This is nothing but your system prompt, right, or your system prompt. Basically, your models or your agent's persona, what it will do. So you are an incident triage agent. Classify the customer problem into P1 and P4. So this is the severity guidelines. For now I have just kept very simple uh, instructions, but you can obviously play around and create more good instructions, and return a concise summary and rationale that references impact, the scope, urgency, right? The build agent method is nothing but pretty simple. Okay, it is getting the environment variable bedrock model id, or it is defaulting to this. Okay, so it is creating the model, and we are setting the temperature to 0. Okay, and then we are returning the agent, and basically it accepts the model. Output type is severity result. So if you see, there will be this kind of a format. This will be the output type of that agent. It will give you the severity level, description, summary, and rationale. Okay, that is what we want. And if you see the severity level, we are already telling that it is P1, P2, P3, or P4. It is intelligent enough to understand all this, and it will return you back in that particular format. Okay, this is the output type. Instructions, we gave this, and maximum retries we are giving as 2. If some kind of problem happens, then it will retry. Then we are building the agent. Obviously we are exporting, and we are building the A2A agent. Basically, when you call the .A2A over here, it will convert it into an A2A agent. Okay, that is the protocol that we just discussed. It's pretty simple, right? Nothing very fancy or something to understand. Now it is already running, but what I will do is I will close it up and I will rerun it. Okay, so I have activated my virtual environment. So I'll also show you some some dependencies that you need. You can install it out. PydanticAI, fast A2A, fast API, UVcorn, because this is a UVcorn server, and Boto3 and all I have just kept it. I don't need it now. Maybe I will need it later. I may be needing the Boto3 client later on to interact with some other services later on. But for now, PydanticAI, fast A2A, all these things you can just install everything. It's not a problem, and this code I will provide you. I'll upload it to a repository, and I will give you the link in the comments or in the description, and yeah, you guys can go and play around. Okay, don't worry about these files, guys. I was just playing around with some things. For now, the main files that you would need is models, where we are defining the model or the output format, main.py and app.py, where the actual agent resides. Okay, now I have also noted down some commands over here. I'll also give this as part of the description or as part of the comments along with the code. Nothing but how to create a new environment, and how to source your environment and install the requirements. That's it. Now to run the app, it is pretty simple. You can use any of these commands. If you want more logging or debugging, you can use these kind of commands. And now if you see this particular command, I'm going to grab and I'm going to run the particular server from here. Okay, so we are going to run this command, UVcorn app, because if you see the app.py, the particular app which is our agent, right, it is there in the app.py. So we're going to mention that, and we're going to mention the port, which is 8000 in this case. We're going to run it. It is starting the server process 32465 whatever. Now let's go to my Postman. I have already created some endpoints. I mean, just the requests I've created endpoints already exist anyways. The first thing that I want to show you is the local agent card. I mean, it is running in the local for now. Obviously I'm going to deploy this agent later on in some as a lambda function or something in AWS later on, but for now it is in local. So as I told you, it will expose something like a agent card.json, and when you call this particular endpoint, it will show you the details of an agent, what the agent can do, what the agent is. So you can see my agent, an AI agent exposed as an A2A agent. You can change all this metadata. For now it is just a normal agent, so it is giving you all these things. And Yeah, see, you can also enable streaming for an agent. I'll explain you what streaming is in the upcoming videos. We're going to explore a lot more on these agents. Push notifications and state transition history also false. For now, these capabilities are not there. Now you can also agents can also pause their execution, guys, for because sometimes human interaction or human approval is also necessary. We are going to also cover that later on in another video. Obviously, this is just, we are starting out with a particular agent. Now let's move on to the actual agent call, how it will do. So this is JSON RPC message over HTTP, right? And if you see here, we are, don't worry about this format, it will be like this. The only thing that you need to worry about is this parts. Okay, we are telling all checkout payments are failing across regions, there are no workaround. This is the customer query, and I will just put one more. There is a huge outage. Okay, now when I send this message right now, you see this is fast A2A. You are getting a response in 13 millisecond. What it is giving you is a task ID. Now if you copy this task ID, you can poll it and you can know the status, what has happened actually. Now this is where you can send another JSON RPC message with the task ID, because the particular process is running in the background. And if I give the task ID here for the agent, and if you see the state is completed, I mean the agent has finished processing the message. And if you see in the here the result, it is telling the severity is P1, summaries all checkout payments are failing across region, no workaround available. This is a complete outage. So this is the rationale, because I added one more line in the end, right? This is a complete outage impacting all customers and their ability to complete transaction, which is critical and has no workaround. So this is a P1 severity, right? So this is some metadata it is sending, for you to refer. And this is how, you would communicate with an agent. Now I'm a human communicating with an agent, so I'm directly calling this JSON RPC over HTTP as an A2A protocol. But later on, I would show you how an agent will communicate with another agent. That is obviously, that is why the A2A protocol exists, guys. Okay, I guess that is all that I wanted to cover in this particular video. All this information like the GitHub repository and the commands, I will be sharing with you in the description or in the comments. So video in the agentic series, what we have done is basically created a simple agent, right? We have started with how to create an agent and we created a simple agent, right? So currently, if you see the state of an agent, so if this is our agent, okay, this is what we had developed in the last video. You can check out the last video to get a more idea, but I'm going to tell you what we have done till now. So this is our agent. So basically, the input to our agent currently is a customer complaint, right? The agent processes that particular complaint, okay, assigns a particular severity level like P1, P2, P3, P4, right? Summarizes and basically, kind of structures the particular complaint and then returns back the response, right? That's all our agent is doing till now. But we had more and more ideas of, this is very simple to create, and you should not create agent just to do this, right? You can do this using Chatgpt or any kind of conversational LLM as well. Now, what else an agent can do? See, an agent is intelligent, right? Currently, you are the person responsible for increasing what your agent can do. Currently, it is doing a very simple task, categorizing and returning the response. That's it. So, obviously, for doing all this stuffs, right, we have a LLM. Currently, we are using Nova Lite.
because it is very cheap, and if you are creating a very nice prompt, then you don't have to use a very big model like GPT 5.2 or something like that. Everything depends on how you are using your prompting skills. Okay, now let's enhance this agent. If you remember my first video on the agentic series, I had talked about something known as tools of an agent, right? So if LLM is the brain of an agent, tools are the hands and legs or other stuffs of an agent, basically. So the LLM will direct the agent to use a particular tool at a particular specified time. Now, for example, we are categorizing the customer complaint. Then what is the next thing that you want to do? Ask yourself as a human being. So once we are finding a severity, I mean, we are categorizing the severity, we want to send a notification to the users, for example, right? To the concerned stakeholders. So we can have a tool, for example, tool number 1. So T1 or tool 1, we can have something like a notification tool, right? So this tool is responsible to send a notification, send an email notification, right? So the agent will decide, I mean, based on your prompt, whatever you are going to give, at the correct time, the agent will decide when to send the notification. Now this is where the intelligence comes into the picture. Now you would understand why the agent is intelligent. Previously in a microservice, you would do step by step, coding you would do, and whenever the correct time is, you will only call the method to send the notification. But here you just define the method as a tool and instruct the agent that, okay, once you are done summarizing the particular customer complaint, you use this tool. The agent will intelligently understand what you want to do and basically trigger the tool at the correct time. So one tool we will create is the notification tool. The second tool that we will create, that is tool number 2, which is basically, for example, storing the incident in DB. So this can be, you can name it as storing tool or something like that, whatever you want to understand. Okay, now we still want to keep it simple, so we are going to create only 2 tools. Okay, one to notify the stakeholders that, okay, this kind of incident has occurred, the agent will do that. Second is storing the information in a DB. Okay, pretty simple to understand, right? Now what are the steps that we are going to follow in this particular video? Obviously all of these things, codes and commands that we're going to use, I'm going to update it in that particular GitHub repository. Okay, you will be able to get all the codes and everything, right? So the first thing that we will do before we modify the agent is basically do some pre-work or groundwork. First thing is, I want to create a DynamoDB table, because we have one tool, right, where we want to store the particular incident. So we have to create a table over here. So you can use this AWS DynamoDB create table CLI command. Obviously, whatever AWS CLI commands you want to run, there is a prerequisite that you must have configured your AWS credentials in your particular terminal. If you haven't configured, then you can run it on Cloud Shell as well. If you are having doubts, then you can go to the console and go to Amazon Q and ask the questions. It will guide you on how to configure your credentials and all that. Okay, I also have a dedicated video on IAM. You can go and have a look about how to configure the access ID, access key, all of these things in your particular terminal. But better way is to go and check out the Amazon Q thing, because it will give you step-by-step information about your problems or whatever you need. Okay, first thing we'll do is we're going to create a table named as incident table. Okay, and there are some attribute definitions I want to have is incident ID I want to keep, and attribute type. Attribute type I want to keep key schema. Attribute name is basically I want to keep incident ID, and key type is hash, and billing mode you can just keep it as pay per request. I mean, per request that you give the particular to the DynamoDB, you will be charged on that. very cheap. You will not even notice. If you're on the free tier, good to just do it. Next thing that I want to do is create a SNS topic, because obviously we're going to use simple notification service to send out the email notification to the particular subscribers. Okay, so first we'll create a topic. Obviously, if you know the SNS thing, there will be a topic where the notification will be pushed, right? And if I, for example, my mail, right, mail ID, it is subscribed to this topic, it will receive all the notifications which are pushed to the topic. Okay, so this mail ID will receive. That is the concept. I also have a dedicated video on SNS as well. You can go and have a look. So I'm going to create a topic, incident notification, and then I'm going to subscribe the topic. So this is nothing but the ARN, okay, resource name. After you create a resource in Amazon AWS, you would get a ARN, Amazon resource number. So you just take that ARN and you put that, okay, this is the topic ARN, and protocol you want to use as email, okay, and this is the notification endpoint, and this is the mail that you want to get subscribed to. Currently I have put my email, right? Then you can export. Basically this environment variables are being used in the code, so you can export it out, or you can, in the code also, there is a default setting I have kept. You can copy paste your incident table name and the topic ARN there as well. Otherwise you can use the export commands. Okay, and if you want to check out the number of items, if it has been inserted or not, you can use the DynamoDB scan command, but we'll go to the console and check if it is working or not. Okay, I hope that is making sense. Now this is the prerequisites, I mean some of the groundwork that you have to do before we move on. And now we are going to go to the code and have a look through the code. Now the important thing that you need to understand is this particular prompt that I have kept in the for the particular agent. Okay, this prompt is the instructions for the agent. So first of all is the guidelines on how to classify your particular request into the complaint into the severity P1, P2, P3, P4, that I have kept it here. You can add more details as well. This is just a demo, so I just don't want to make it more big and it will look a little bit messy, so I just kept it small, but you can obviously add more information if this is use case you want to use in your real world case. Okay, return a concise summary. After you decide the severity, summary and rational, I am telling call the store incident. This is the tool name basically. I will show you the tool. That is nothing but a function, Python function. Call the store incident with the original customer text plus your severity, summary, rational. Okay, I'm just telling, this is a normal English I'm doing. I'm not doing method calls, nothing. I'm just telling in the prompt only, and the agent will be intelligently will be able to understand what it needs to do. Call the notify incident with the same field. So first it will call the store incident tool, and next it will call the notify incident tool. Call each tool once. If a tool has already been called, do not call it again. Now I had to add this particular prompt because sometimes the LLM might not be able to understand, and it will think that this tool, it might call it again and again. It will be an infinite loop. Okay, it will keep on calling. So you have to have some guardrail or some constraint. That is why constraints in prompts are very, very important, because it will instruct the the LLM when to stop, how to stop, and what are the basically the guidelines. So you have to make sure that your prompt is very concise, because the first time I tried this out, it was calling it indefinitely. Okay, I didn't know what to do. That's why I had to add this particular prompt over here. Okay, do not mention tool calls in the summary or rational, because this also I had to add, because what it was doing is as a response it will return you the summary of the particular incident that it did, right? But what it was doing, it was also giving out the response that I'm calling this tool and I'm calling that tool as well. So to refine more on that, I had to also mention that do not mention the tool calls in the summary or the rational. Then return the final response as the same structured output. Okay, whatever it was returning, it will return, but on the top of that it will call these two tools after it has done the classification and done the summarization. I hope that is clear. So as I told you, I have kept two variables over here. Okay, if you want to just give the table name and ARN name in the code only, you can give it here. It will pick it up and it will run. Otherwise you can use environment variables. Okay, the two things that I want to use, first is this method which is store incident. Okay, so store the incident in DynamoDB. Okay, it is getting the args. Okay, and there is one small method check that I'm doing. Should it execute the tool or not? Just a guardrail I have put over here. If the tool has been executed before, it will store the count in the context. Okay, if the tool has been executed, that this is the store incident and this is the context, it will not execute it again. Now how will I receive the context? We are receiving the context here. Now if you go through Pydantic AI documentation, okay, this is if you go to tools and tool sets over here, if you go to function tools, you would understand how this context and all this thing is happening. You can basically pass on metadata to various tools that you are using in your agent. Okay, for example, some messages or some instructions that in the tool that you want to do, or some variables that you want to use in the tool. Obviously you need all that. If you need all that, you can pass it on via the context. And in here what I'm doing is I'm just passing on the if the tool has been executed or not, that I'm passing in the context. Okay, now if tool has been executed, will skip the duplicate store incident. Now basically this is just a, I mean, it should follow the particular prompt only, but I thought, you know, I'll just keep one more check over here using the context. Anyways, we are getting the context, but it doesn't get executed because the LLM is intelligent enough to understand this, that don't execute it more than once. It is just if sometime the LLM misses, you know, the LLM makes mistakes. Okay, you can't trust it completely, then this one will be in the action. So then it gets the table name, and then it just checks if the table name is there or not, and then we are creating the item, okay, based on the data that we have, and then we are just putting the item into the table. Simple. This is nothing. One more method or one more tool that I have is notify incident. Obviously we are getting the context, severity level, summary, and customer text and all those things. See, these things we are not calling anywhere. Okay, the agent is intelligent enough that, you know, all this data that the method needs, it will automatically pass it on, and you just need to use it in your method. Okay, so it's getting the topic ARN, and then it is just creating the subject and message. These are all nothing, you know, syntax is basically, you can get the syntax anywhere, and nowadays we have codecs and all those things. You can easily generate this code. Only thing that you need to understand is the idea behind it and what is happening over here. Okay, then we are just Boto 3 obviously is AWS client you can use to interact with AWS services, and then we are publishing the notification into the particular topic, and as my email is subscribed there, it will you know, come to the particular email. Okay, so that is all that I want to see. Pretty simple code. You can have a look to this. Obviously I will update this in the GitHub repository, and after that basically you can have a look and you can just try it on your own. Now let us run this agent. I'm just gonna go and copy the command to run the agent. Where is it? Okay, let me just grab this guy from here. I'll just grab this guy over here. There's a command. You can go and have a look. In my GitHub README, the command should be there. So I'm just gonna, okay, it says our address already in use. I'm gonna just create a new terminal. Let's try it out here. Oh, no. I ran the DynamoDB command, my bad. So I'm just gonna go back and get this command to run the app. Okay, it has started now. Okay, now I'm gonna go to Postman over here, and so basically what I am going to do is all checkout payments are failing across no ground. There is a huge outage. I'm gonna just send this thing. Okay, obviously you'll not get the response. We have seen this in our previous video. This is a polling mechanism, asynchronous fast A2A server. So you would just get the task ID. So you have to grab the task ID, right, and you can just put it here, basically poll the task ID and check if there is some issue or it has been completed or whatnot, right? So I'm just gonna check out this thing, and it says the state has failed. I don't know what happened over here. Found out the issue why it was failing. Basically, I forgot to export the incident topic ARN and table name, which is basically it is using the tools are using. So I exported it, and now other agent is running basically. So I'm just gonna go to my Postman again and basically call the agent and grab the task ID and go back over here and basically paste in the task ID, the new task ID, and click on send. Now if you see, the state has been completed. Okay, now it is giving the summarized result that you need, and obviously the tools call has also been done most probably. So I'm just going to go back. So this is my DynamoDB and my incident table, and I'm just going to refresh it, and you can see that one this is there basically. So if you see, so this is the rationale that has been stored here. Severity is P1 and summary is the all checkout things are failing, right? This is the customer text. Now let me go back here. I have received the particular email notification as well. So as you can see that how the agent is intelligently doing all these things. We just specify what it needs to do, and according to the prompt and the LLM, it understands at what point and at which point I need to do all this stuff. So it basically does it. Now that is all for this video, but I just want to just quickly touch base upon one other thing, okay, that we are going to cover in the next video. Now a lot of people will have the question that currently we have created two tools, okay, one is the notification tool and another one is the store incident tool, right, which will store it in the DynamoDB table. Now people would think that what if there are multiple agents, right, and this tool needs to be used by another agent? That is a very valid question. Now currently, obviously, in the current scenario, we cannot expose these tools outside of this particular agent because it is residing inside the agent. So for answering that question, we are going to cover a very critical concept and very important concept, and it is just the buzz nowadays in agentic AI, that is known as MCP Server. Okay, so MCP stands for Model Context Protocol. So it's kind of a protocol, like soap or something like that. So basically this is very, very important to understand if for tool discovery between multiple agents. I'm going to cover this in detail in the next video, guys, so don't worry. So I've just wanted to tell this because so that you guys will know that okay, we are going to cover all of these things as well. Is on our knowledge of agentic AI development, and we already have a very decent knowledge. We have gathered a very decent knowledge about agentic AI development because we understood what agents are. In my previous set of videos, I have explained it. You can go and have a look. What agents are, we developed a very basic agent and we developed some tools for the agent, right? We kept on enhancing the agent, right? Now we will enhance it further again. So in this video, we're going to talk about a very, very, very important, actually it is the most important aspect of agentic AI development. We're going to talk about MCP servers. Okay. So if you have followed my previous video, we had in my incident agent. So basically I'm developing an agent throughout this series, right? It's a complete hands-on thing. So basically in the last video, I had developed two tools for the agent, right? So the tools were an email notification tool. So whenever the agent wants to send some email notification, automatically it will pick up the tool and send a notification. And then I had developed a store incident tool. So basically if the agent wants to store it to the database, it will pick that tool up and it will automatically store it in the database. It will all do intelligently. You don't have to invoke any tool by manually. But let's understand why do we need MCP servers? Why did this thing came into the discussion? Now every agent needs tools, right? You have developed one agent, someone else has developed one agent. Everybody needs tools, right? And sometimes it may happen that you have developed one or two tools which will be shared by multiple agent. I mean, agent number one might need a tool which the same tool might be needed by agent number two. And currently what we had did is we have created the tools inside the agent code itself. So if agent number two wants to access that particular tool, it is not possible because it is kind of very closely coupled in the particular agent code itself. Only that agent knows about those tools, even though it is using them intelligently, but the method definition is directly embedded in that particular agent. So every agent integration becomes custom and very brittle. It kind of becomes a standalone application which we don't want. We want as much freedom to the agents as possible, because they are intelligent. They should be able to discover tools very easily. That is why the MCP server came into the picture. MCP is like a USB-C for AI. So basically, if you create an MCP server, right? If you create an MCP server, which you see over here, that this MCP server can be used by any kind of agent, or even some of the just a minute. No, I am not able to. Okay, it can be used by any kind of agents. First of all, MCP servers. Okay, and it can be used by some kind of coding assistants like Claude or Codex, whatever you use, right? You can also integrate with them as well. It's kind of like a USB-C. You can input anything into an USB-C. You can input a speaker, you can input earphones, whatever and whatnot, right? Your charger, whatever. So we had to, they had to make sure that whatever tools an agent uses, it is easily available to the agent. So they developed a MCP, and MCP stands for Model Context Protocol. Okay, and this protocol was developed by Anthropic I think in 2024, towards the beginning of 2025. So this protocol is relatively new, right? So this protocol is nothing but a protocol which agents and other AI application use to discover tools or any kind of other information, metadata information, or a source. Basically, it is not just for tools. You can expose any kind of information via an MCP server, and MCP stands for Model Context Protocol. I hope you are getting an idea why this is needed. Okay. So what is Model Context Protocol? To understand it very cleanly, it is like one of the most clearest attempts so far till now that I can think of, to standardize how AI application discover and use external capabilities, right? And keep in mind that MCP is an open protocol, right? It is an open protocol which is used for connecting AI apps to tools, datas, workflows. Lot of things are there, right? Nowadays, generative AI and AI is not just chatting, it is communication. Communication has become the key if you're going to work with agents, chatbots and whatever and whatnot, right? Data sharing and data access is one of the most crucial aspects of how your AI based application work. Okay, so using Model Context Protocol, you can expose tools, you can expose resources, and you can expose prompts, whatever prompt templates, right? Nowadays, reusable prompts are very the trend nowadays. Okay, because nowadays you don't have to write the same prompt again and again. You can save it via prompt templates. Now AWS also has prompt templates. And if you know, there is in SAP, if you know about BTP platform, SAP BTP Business Technology Platform, if you know about AI Core, they also have their own services. There is something known as prompt registry there, right? And you would be able to save your prompts. You can version your prompts also there. You can have a look if you are interested, and if you want to, want me to make a video, I can also make. Anyways, so if you want a dedicated video on prompts, I already have a dedicated video on prompts. If you want more information about prompts, because there are a lot of techniques of prompting, which will heavily save your money and resources. You don't have to use very large models. Even GPT-4o mini is also okay if your prompting is very good. Few shot prompting, meta prompting, all of these are very nice prompting techniques. If you want me to make a video, just comment it down in the comments and I will make it. So I hope for now, let's get back to this video. So you understood what is model context protocol, right? How it works and basically why it is needed, right? To expose all of these resources to an agent or an AI application, MCP is very, very important. Okay. Now MCP architecture is pretty simple to understand. Okay. Now if you see, there are certain things, right? So there is a host. Host is nothing but the agent itself. For example, you have an agent, right, that you have developed. Okay. So now what is the requirement is that this agent wants to use some tools, right? For example, this agent wants to use some tools. Now we need some kind of library to connect with the MCP server that should be inside the agent itself, and that library comes as part of very many SDKs in Python, Java, whatever. So it is generic, so you don't have to worry about that. So that that agent will be responsible to set up the client. Now even whatever protocol you have to communicate to get the data from the server, for example HTTP protocol, you need some kind of a client. If you have worked with Java, you would know that we need some kind of a REST client or HTTP client, something like that, to communicate with APIs. Similarly, if you want to communicate with MCP, model context protocol is nothing like a rocket science kind of a thing. It is just a JSON RPC server. It is just JSON RPC over HTTP, right? Let me just change the pen. It is very thick. I can do with this pen. This is better. It is just JSON RPC over HTTP. JSON RPC is the message format that you send across in your particular call to the server, and HTTP is HTTP. I don't have to explain about that. So your agent is responsible to contain the client. Okay. Now this client will be inside the agent itself. That is nothing but the SDK that you will use to connect to the MCP server. Now comes the MCP server. So here comes the MCP server. Like we have our resource server, right? Our backend server, which is basically responsible to serve the data to the client. That will be the MCP server in this case. Okay. Now this MCP server, if the agent wants to communicate with the MCP server, it will just directly establish a connection session. We'll learn about it, in detail in a bit, how the particular session is established and all those things between the agent and the MCP server. But for now, just understand that this is the client side and this is the server side. Okay. All the tools, resources, prompts and whatever we understood is residing in the MCP server, and the agent will just make the call to the MCP server to discover all the things that is there in the MCP server. Okay, I'm hoping that is making sense. Now, how agents communicate with the MCP server? It is a process. It is, many people will not explain you how the MCP communication happens. Okay. I'm also going to show you, using a postman or curl commands. Like I will act like an agent myself and I will show you how this particular agent actually communicates to the MCP server. Because if you sit for an interview in, for example, in a company for a AI developer, these questions will be asked, because anyone can establish a connection. How the connection is established is very, very important, because sometimes you also have data that needs to be protected. You can't just send over the data. If you don't know the process properly, you can't intercept the data or, mask the data or something like that, right? And those questions are absolutely mandatory to be asked. Okay. Now let us understand how agents communicate with the MCP server. Now let's look at this particular communication flow. Okay. First step is connect. This is the first step. Connect is where the host that we saw, the host over here, right, which is your agent. The host connects to an MCP server. This can happen in two ways, to be honest. One is the STDIO way and another one is the streamable HTTP, or normally HTTP. I'm just going to mention, like I told you in that particular previous slide, I told you that It is JSON RPC over HTTP. So STDIOA, you're not going to talk about it. It is just a local kind of a setup where you keep the tools basically locally in your agent, which we have already tried. So we don't have to worry about that. The only thing we are going to focus on is the HTTP way, because the MCP server resides somewhere else. Obviously, you need the HTTP protocol. Okay. Now, this, as I told you, this HTTP is a modern transport using a single endpoint that supports, kind of operations like post or get operation. You can, that's what I told you, right? This is just HTTP, JSON RPC over HTTP, right? You are going to do the same post call, the same get call. It's just that the contract in a way, like contract is what? In terms of API, also API is like a contract between microservices, how microservices communicate with each other. Similarly, here also the MCP is like a contract between agents, how one agent communicates to another agent, something like that. Okay, so understood. First thing is the connect phase where the host connects to an MCP server. Second step is the initialize step. Okay, now the client and the server initialize the session and negotiate capabilities. See, MCP is not a stateless kind of a server. It's a stateful. So MCP means stateful. Keep that in mind. So an agent will communicate with the same MCP server multiple times, and the session needs to be maintained between them so that the memory will be maintained. What was the previous thing that I did with the MCP server, right? Think from the perspective of an agent, right? So MCP is not just random request, like a stateless request. It has a life cycle, and in that life cycle, the agent will remember what it did. What was the previous input that I got from the MCP server? What was the previous tool that I used? Because if it loses all that context, right, then your prompt is of no use, right? Because it will not remember what it did previously. So it is very important that the session is being initialized between the agent and the MCP server. So that is the next step. Basically, I will show you that how you get a session ID from the MCP server and you use the same session ID to actually do the further requests. I will show that in a minute, okay? Don't worry about that. Next is the discover. Once the session is established, next comes the discover phase. So discover is nothing but what does the MCP server offer? The agent asks the question, because till now it doesn't know what tools, whatever resources are there in that particular MCP server, right? Because it is foreign to that particular concept. So instead of hard coding tool knowledge that we did in the previous video where we we kept the tools inside the agent itself. Here, the client can dynamically ask the server, what are your capabilities? Okay, so there is a method. So the agent can, once the session is initialized, I will show you, it is all in the initialize API call, all those calls we will see one by one in action. So in the discovery phase, the agent will call one kind of a method of that particular MCP server, that is tools/list, this particular thing. So this particular call will list down all of the tools that are available in the MCP server. A tool is nothing but, like we had developed a tool, right? We know what tools are. Basically, it is a hands and legs of the agent. If an agent needs to send a notification, it will invoke the notification tool. If an agent needs to store into DB, tool. If an agent needs to, send the calendar invites, a tool. It is nothing but a function. Previously, the function resided inside the agent code itself as a tool. Now we are exposing it as part of the MCP server. Okay. So if you want to expose, tool is nothing. Tool can be anything. It can also be an API as well. An API which is giving you some response or some data. So it is an API call only, just that you will wrap this API in a MCP server. So the API will connect with the DB or whatever, right? It will return back the response. Then the MCP will be responsible for maintaining that contract or the particular format in which the agent will receive the response, the metadata. It will wrap that particular response in that particular format and it will send it back to the agent. That's it. Nothing. MCP server is just a provider. okay, for the tools and other resources. Okay, it is just a protocol we follow for agents to discover tools, resources, prompts, and whatnot. Okay, next step is the reason. Now the model has context. Whatever the LLM you have used in the particular agent, it has context. What tools exists, what they do, what arguments they expect, what resources are available. All these things now the agent knows. Now the LLM which you are using in the agent, now it has a very nice idea what it is, right? Right, now reason we have, now it has context and everything. Now we are ready to invoke or call those tools whenever needed. Now for example, in my incident agent that I'm currently developing, okay, now when the initialization phase and all those things happen, when the agent knows that in that particular MCP server, for example, it when it did the tools list, right, thing, it got two tools. One is the send notification and one other is the save to database. These two tools are available. Now the agent knows. Now whenever it needs to use that particular tool, it will just use it because it has already discovered those tools on the MCP server. Okay, I hope that is making sense. So that is the invoke phase where the tool is used by the agent. Okay, next step is return structured results. This is nothing but the phase where the MCP server actually returns back the response, and that response will be further processed by the LLM and it will be returned back to the user, whoever has invoked the agent. Okay, I hope that is making sense. Let's move on to the next slide. Now let us understand, we have already known this difference, right? Now hard-coded tools and with MCP, what is the advantages over MCP? Using MCP, you discover new tools at runtime itself, reuse across multiple agents and apps. Metadata, drives understanding. So sometimes what happens is, for example, there is no hard and fast rule that you have to use MCP server only in your particular agent, right? You can use API calls also. So for example, if you have an agent, you can do an API call, nothing, no problem in that. Nobody is stopping you. You can do that. But the thing is, to do the API call, you have to keep the API calling logic in the agent itself, which is not a problem in any scenario. But let's take an example. Sometimes what happens is the API structure changes or the contract changes or the way in which the API used to work is not working, for example, or the path changes. For example, previously it was v1/API, now it is v2/API. Now what will you do? Now, and the agent cannot, because the API is not intelligent like a MCP server, like it communicates with the MCP server. It will say that no data found. So in that case, you have to go manually inside the agent and then change the code and redeploy the agent and whatever and whatnot. But if this API resides behind an MCP server, even if this contract changes, you have to change in the MCP server. The communication between the MCP server and the agent will not get impacted, right? Because in any way, if the agent, for example, is having some kind of problem with the MCP server will return a very simple response saying that something has happened. So the agent will give you back a very nice response. The next question comes, will MCP servers replace APIs? A lot of people might think about this, because nowadays everything is about AI. Are we going to get rid of APIs? But the answer is no. It will not get rid of APIs, because still APIs are a way where microservices communicate, and we still need microservices, right? You can embed your agent inside your microservice, but still if you want to do microservice to microservice communication, it will use APIs, application program interfaces. Nothing is going to be changed. Now, if, as I explained previously, if an API is to be used for an agent, it will just be wrapped in an MCP server. It will just be another way to provide that information in a different kind of protocol. It is not going to replace APIs, because the roles are different. It is exposing backend business logic, and this is exposing tools and context to AI applications or models or agents, right? Focus is user facing endpoints. It is just AI facing discovery. Okay, it is not going to work with your UI applications or something like that. That is different, this is just for AI use cases. Interfaces are different, and this is JSON RPC over HTTP or STDIO streams. Discovery is also different. Clients must know all routes up front. Yeah, because obviously if it's a front end application or something like that, you would obviously have your API definition, and your structure will be there in your front end application. It will already be there. So that is different. But in case of MCP, the agent automatically discovers the tool, like we saw the steps, right? How an agent interacts with a particular MCP server. So API stay in the end. MCP standardizes AI integration and discovery. That is what is very important to understand. I hope that is making sense. So if we talk about some real world use cases, you can integrate MCP servers with developer assistants and IDEs like Claude, Code, or Codex, or Cursor. These are all we know about developer assistants, right? And you can, for example, in your Claude, in your VS Code, you have installed Claude Code there as an extension. Cline, we tell it as Cline, right? That is Cline. I'm sorry. Right now, while you are doing a development for your organization, there is some softwares that your organization use that Claude or Cline or Codex doesn't have any information about, right? For example, there are some internally used tools, because these AI models will only have the information which is publicly available, right? Now, if for example there are certain things that your company uses and they have not exposed to the outside world, then in that case your AI models will not know. So what you can do is you can expose that as an internal MCP server. You can do that, which is well protected and authenticated by your tokens and all those things, and then you can integrate it in the particular client tool or something like that behind a proxy or something, right? In that case, it can easily securely connect to that your organization's MCP server, and it can use the tools there and can generate code and whatnot, right? It is so cool, right? So this is one of the very best use cases of using MCP servers. Enterprise knowledge assistant, I mean, you will have your agents and your own chatbots in your organization, and you can integrate it easily with MCP servers and whatnot, right? You can use the A2A protocol to connect your chatbot to the agent, and the agent then can connect with the MCP server using the MCP protocol, basically. Design to code workflows, incident ops and response. These are just applications of agents and MCP protocol, nothing more than that. Okay. There are certain public MCP servers. I'm going to show you one MCP server of OpenAI itself. This OpenAI docs are there at developers@openai.com. I'm going to just show that flow that we saw right previously. I will show you how the initialization and all those things happen. Okay, how the tools list call happens, and it will list down all the tools that are there in the MCP server. All these things I will show you. But there are a lot of public MCP servers for you to play around. For example, GitHub has its own MCP server where it exposes, some public repositories or data about a lot of other things, right? OpenAI also has that. Yeah, okay. A file system, fetch, Git, memory, everything. There are some aggregate servers as well, which many companies have made it public, so that they can easily integrate with other AI agents itself. So yeah, have a look out for that. If you want, I can give a list of the public MCP servers in the description or in the comments. You can have a look. But yeah, in this video, we are not going to integrate it with our agent itself, because it will take a lot of time. I don't want to overwhelm you with more knowledge. In the next video, probably I will create my own MCP server. I will show you how you can create your own MCP server and how to integrate it with your agent also. I'll show you that. Okay, now this is the format. This is the JSON RPC format, how it looks. MCP looks like on the wire. So if you see, there's a JSON RPC version, ID is there, params are there. The basically data would be mostly be there in the params. Okay. If you remember, I had showed my agent calls in the Postman. I don't know if I have it opened or not. Yeah. So if you see, this is also an example of JSON RPC. where my agent, I am communicating with my agent. Okay, the A2A protocol is also JSON RPC over HTTP only. Okay, it is the same kind of protocol, same kind of format it is using. So if you see, this is how we are getting, this is the format. Okay, you don't have to worry about all this because all these things are handled by the agent and your MCP server itself, right? Only when we're manually testing or doing something like that, then you can try this out. You have to follow this particular process of as I showed you, the MCP process, right? How the agent communicates with the MCP server. You have to follow that when you're doing it manually. But I think Anthropic provides something known as MCP Hub or something, MCP Tester or something. I forgot the name. You can check that out. So you can install, it's a command line tool, and you can easily test out your MCP servers using that. You don't have to do this back and forth session thing that I showed you. That's just a method, it's a flow, and it will be taken care by the particular client itself, okay, or your agent itself. So don't have to worry about that. Okay, so tools list, this is one of the things that I will show you right now, how it works and everything. Okay, this use case I'm going to implement in the next thing, next video. I will enhance my agent further with this particular MCP server and my own MCP server basically. Some risks and cautions. Okay, make sure that whatever MCP servers that you create, if they contain some data which is very sensitive, then make sure that it is trusted and it is authenticated. Prompt injection and tool poisoning is also one of the things. Hackers and all, they can while you if your communication is not secure enough, they might inject something while the communication is happening between your agent and the tool, and your agent will receive some malformed data or some data that is not needed, and it might affect your particular application. Okay, it will corrupt it. Permissions, very, very important. And one thing to keep in mind is that MCP is not magic. Okay, it standardizes the format or the way in which your agent communicates with the particular how agent communicates with the MCP server and discovers the tools and resources, but your base security and authentication always remains the same. If you are using OAuth, keep using OAuth, keep using secret and secret ID, access key and access ID, whatever you are using, keep using that. Just because you are converting into an MCP server, don't make it that I want to make it available to everyone and just expose all of your data. AI is good, but make use of responsible AI. I always tell that in my videos. Okay, and now we'll just have a little bit of hands-on. I have kept all this commands. Sorry, I don't know why I'm fumbling. So OpenAI public docs MCP server is officially documented at developers.openai.com/MCP. If you go there, this is the MCP server. Okay, now we have to this particular this method is not allowed on the browser, so we're going to do some curl commands. Okay, so first of all, as we know, I'm going to export this MCP URL, okay, in my terminal. I'm just going to open up my terminal. Okay, I'm just going to go for full screen. So I exported my MCP URL. Now first thing that happens, see, this is a public server established, exported by, not exported, made available by OpenAI. So the session ID concept is not here. Okay, it is publicly available, so they made it easier to actually communicate things. But as I had explained, all of these process that happens in the communication, I will do that. So the first thing I want to do is basically do the initialize phase, right, where we get the session ID actually, but you will not get the session ID in this case. But when I will make my MCP server in the next video, you would see how the session ID is getting generated and how you will communicate using the session ID. But this is a public MCP server, so now it will not return anything. Okay, it will not give you back the session ID because it is not needed. Okay, they have made it easier. Okay, so I did a post call to that MCP URL, and I sent the method as initialize, and it is just sending me back a very basic response over here about the server info, version, JSON RPC version, and the ID, right? We saw the method over there. So this is the initialize phase. If you had a session ID, then basically what you would do is you would use that session ID which you got from this initialize call, right? And basically you have to send back the session ID and establish the session over there, okay, using this particular thing. So you would say that, you know, I have initialized the session using the session ID. So the agent will basically say, I have initialized the session with the MCP server using that particular session ID. So I'm just gonna call this method, but it is useless because here we are not getting the session ID. So we don't have to worry about that. It is just saying that 202 means that, you know, it is initialized. Okay, whoever you are, it is initialized without the session ID itself. Okay. Okay, now I'm gonna call the tools list method. So it will list down all of the tools that is there in the particular MCP server. So I'm just gonna do a clear over here, so that because there might be a lot of tools that this MCP server exposes. So I'm just gonna do that. So here are the tools that it exposes, right? One of the tools is search OpenAI docs, okay, and it says the title is search OpenAI docs. Search across platform.openai.com. Use this whenever you are working with OpenAI API, including responses API. It just gives you some other things, right? You know, so I'm going to use this tool, okay, to get some information about, you know, this OpenAI. So to do the tool call, now the discovery happens. Now think from an agent's perspective. Once it executes the tools list command, now it knows the list of available tools that the MCP server is providing. Cool, right? Now I know. Now I just consider me as an agent. Now I know that there is this search OpenAI docs tool that I might use it. So I'm going to use, I'm going to send one more post call over here and use it basically. So what I'm sending in this post call, pretty simple. I'm sending it to that MCP URL. The method is this tools call, and in the arguments I'm sending what is the latest version of Chatgpt, and I'm saying limit as 5. Okay, so if I hit this, now I'm getting a lot of information over here, right? Now you see there is some information, I mean, for sandbox and approval keys, you know, validation file saved to a folder called my data will retrieve the latest version of artifact. Some data I'm getting about, right? I don't want to parse it on right now. So there is some data about GPT-5 codex and whatever, whatnot, right? So yeah, that is what. So using this tool, I was able to fetch some information about the particular OpenAI, and you know, I was able to use one of the tools that this MCP server exposes. I just showed it manually just for you to understand how you construct this JSON RPC message. I mean, not you construct, the agent constructs. You don't have to worry about constructing all these things. The agent will work on its own. Okay guys, so that is all about this video. I know this video went a little bit long, but I wanted to clear up all the theory and intuition behind the MCP servers. In the next video, I will create my own MCP server and integrate it with my agent. It will be a lot of fun, by the way. This concept I'm really liking. And I'm also continuing my AWS AI certification series. If you guys are interested about getting a AI certified, AI practitioner certified by AWS, you can go and check out those videos as well. That series is complete. You know, we have explored a lot of tips and tricks and a lot of concepts over there as well. Go and have a look. Not just for the certification, it will give you a lot of knowledge about generative AI and AI development. Continue getting more information about MCP servers because, you know, they are really amazing. You know, they are like the best friends of agents. When they need something, they call MCP servers, right? But in this video, we're going to talk about how you can easily test MCP servers, you know, because interacting with MCP servers the traditional way through Bruno or Postman or something like that, it is a little bit difficult because, you know, public MCP servers, that is fine. You can directly, you know, just throw a kind of call the, you know, public MCP server through a curl command or through Postman. That is fine. The initialization and all those steps are not that necessary, but you know, internally it does initialize the session between, you know, the particular client and the MCP server, because that is very important, you know, because as I have mentioned before, MCP servers are stateful. Okay, it's not that they gave an answer for a query and then they forget. It's not like that. They will always remember, in a particular session, whatever is happening, or communication, whatever the communication is happening between them and the client. So yeah, initialization of the session does happen with public MCP servers as well, but sometimes the public MCP servers don't need a session ID to be established, especially MCP servers of renowned, kind of places like OpenAI or GitHub MCP servers. Yeah, they are relatively easy to test out. But if you have a corporate kind of a MCP server, which is behind a kind of an authentication mechanism like OAuth or something, then you need to use some kind of a tool to test out that MCP server. Now, in my opinion, as MCP server was developed by Anthropic, right, they have also developed a tool called as MCP Inspector that you can see on my screen right now. So it is relatively easy to install and run this tool. You just have to run one command to actually, run the MCP Inspector tool. So is we're going to copy this MCP server URL of OpenAI, and I'm going to show you how the MCP Inspector helps you. You would know the steps that it is doing in the background, right? Even though it's a public MCP server, that is also fine. So I'm going to paste down this URL over here, and I guess it would need a proxy authentication token, which the MCP Inspector already generates. So it is there. So you can just grab this token from here. Okay. And it would just be a verification that this is the client it is connecting to. Okay, it's just a MCP Inspector thing for now, because if you saw in my previous video, I was able to communicate with the MCP server. It's a public MCP server through curl commands, so you can also try that out. Okay, so once I paste it out, if I click on connect now you can see that it is connected to the MCP server. Now if I go back to my terminal, you would see that there is a client proxy session ID established. Now whatever I would do in this session, you would see in this MCP Inspector. Okay, it is like in one session, once the session is established, I can do anything. I can list down, I can see the tools what it is offering, I can execute a tool or whatever and whatnot, right? So if you want to list down what are the tools this particular MCP server is offering, you can see in the tool section there is one tool known as list tool. If you click on that, you would see these are the tools that are available for this particular MCP server. Okay, now if you see search OpenAI docs, this is the most basic thing that you can do. Basically, if this particular tool that you see, it will help you. This particular endpoint in this tool will help you to search some documentation in the OpenAI, right? So I'm just going to click on this tool. So it will ask you what are the parameters this particular thing supports, right? So search across, so it gives you a metadata also. This is how an agent knows, right, how this particular tool works, because there is metadata information over there. That's why APIs are a little bit restricting, because there is a particular endpoint over there, and the agent has to hit that endpoint and then get the data. Then the agent would know, okay, this is what I'm receiving right now. But if you see about MCP server and the tools, metadata is associated with it. So the agent will know intelligently, because the brain of an agent is the LLM. And once it reads the metadata, it would know that, okay, this is what the tool is offering. So search OpenAI docs. Okay, I'm gonna hit a query, for example, latest version of Chatgpt. Okay, can I put the limit as 5 or something, and then I'm gonna run the tool. So if you see the history over here, first the initialization happened, then the tools list I did, because I clicked on the list tools, right? That happened, and then the tools call happened. All of this steps of establishing the connection and how the data is fetched from the MCP servers, all of the steps I have already discussed in my previous video. Okay, there are various steps. First, the session is initialized, then the tools list is called to know what are the tools and the metadata offered by the MCP server. Then the agent, basically, in this case I am the agent because I am communicating with the MCP server, but obviously you're going to use MCP server in your AI ecosystem or your AI application, basically agents. This is the way the agent will be able to figure out what are the tools of the particular MCP server and all those things, right? So once initialization happens, and if you see there are the tools call happened to the search OpenAI docs. This is the endpoint that it is hitting, latest version of Chatgpt, and if you see the response, it is giving me some response, right? If I expand this out, API to fine tune GPT, some data is it is fetching. I'm not sure if this is the correct data or not, but yeah, it is fetching the data from this particular tool, and that is what I wanted you to understand. So if you have a MCP server, right, it supports all kind of authentication. This MCP Inspector supports all kind of authentication mechanisms and whatnot, right? You can easily test out your MCP servers using MCP Inspector. Okay, I hope that is making sense. All right, so the next part that I want to discuss with you guys is pretty simple. If you guys have installed Cline, right, you know, any kind of you know, chat assistant that you have like Codex or Client, they are capable of you know, obviously they help you in writing code. They are basically your coding assistant, right? But they are also capable of, you know, connecting with MCP servers. And why is that important? Let us try to understand that. See, sometimes what happens is that in your own organization, there are some kind of softwares or tools or that which is specific to that organization, which the public LLMs would not know, right? And same is the thing with Cline or Codex or Amazon Q or whatever you are using as a coding assistant. So to make your coding assistant know, to make your agent know that, okay, I also need to refer to some internal documentations. Now you cannot go ahead and upload internal documentation or confidential information on the you know, public LLMs. Okay, obviously 100% of the companies will not allow you to do that. So what they do is they basically use the LLMs or something like that under some proxy or some authentication mechanism. Okay, and some filtering they do. Apart from that, what they do is they create these you know, private MCP servers for their own organization itself. So if you want your coding assistant to fetch some information from that particular private MCP server, because obviously they need some information with from your organization to use that particular tool or software, right, to write code basically. In that case, you can add MCP servers for your particular organization, for example. And if you whenever you throw out a query, okay, I need this particular help, they will also refer the data from the MCP server that you have specified. Now I'm going to take an example of Cline over here, but you know, you can try out with any coding assistant. The you know, the things are pretty much the same. Okay, the rules that we use. So I'm just going to go to settings over here, and let me check out. Okay, there should be MCP servers somewhere. Let's see. I kind of forgot. Okay, I think it should be here somewhere. I don't know how it just skipped my mind or something. Okay, maybe check out this. Here it is, MCP servers. I don't know why I went to settings, but here I can see MCP servers. My bad, sorry, I wasted some of the time. Okay, you can, there are also a lot of MCP servers publicly. So if, for example, if you want specific something to AWS infrastructure, you can directly install the MCP server over here. There is node manager, there is a document converter, there is financial data, code search, you know, all of these things are there, right? You will be able to understand, you know, directly install a lot of sources from a lot of providers. You know, this is amazing actually. You know, if you want to refer to a particular MCP server, you can do that. But you know, I will show you how you can configure an MCP server. So I'm going to go to a remote server, and I'm going to just pretend that, okay, this is the MCP server of my organization. Okay, so I'm just going to put the server name as OpenAI MCP-MCP. Okay, I'm going to use the same publicly available MCP server. I'm the server URL. I'm going to just go back and put this one only. Okay, it opened up in this Chrome, but that is fine. Okay, let me go back to Cline over here and put the server URL. Streamable HTTP. Okay, add the server. So here it says the model context protocol enables communication with locally running MCP servers that provide additional tools and resources to extend clients' capabilities. It completely states that over here, right? You can use a community made servers or ask client to create new tools specific to your workflow. Okay, so this is what, how it is just telling how to invoke that particular tool from the MCP server, but it is telling that it supports MCP servers. This is the server. Okay, and if you see this is enabled over here, right? You can disable it by just clicking this out. So you can just click auto approve all tools, so that it will be able to auto approve, directly use all of these tools, otherwise it will ask for your permission. Okay, and you can see that list tools is already being done, and it gets all the metadata information about the tools that is being exposed by this MCP server. Okay, that is what I showed in the MCP inspector, right? So that is making sense right now. So I'm just going to restart the server. Okay, and I'm going to click on done, and now I'm going to try to use the MCP server. So what I'm going to do is I'm just going to, I have a predefined query over here. I waste time, I also save some time. It's a give and take kind of thing. Oh, okay, why it copied the, I wanted to copy the just the text, it is copying the picture or something for some reason. Okay, this is ridiculous. I'm just gonna type it out over here. So I'm just gonna say use OpenAI developer documentation MCP server. I'm just gonna say use the OpenAI MCP server to find request schema for the responses API tools field and summarize the report. To find something, I will just say to find the latest information about the Chatgpt models. Let's try this out. Okay, so it is actually connecting to the particular MCP server, and it is returning me back some information, obviously. Okay, it's a lot of information it seems, but as you can see that, yeah, it is doing something. It is actually communicating with the MCP server, and it is getting me the information. So it is pretty see, it is already telling the user wants me to use the OpenAI MCP server to find the latest information. So I should start by, yeah, it is doing whatever it is, right? See, it is doing the hits and it is giving me the response. So yeah, it is working. So if you go in agent mode, it will again, if you wanted to use the information that it got from the MCP server and write some code, you can use obviously Cline in agent mode, and basically it will also write code for you if it is applicable. Let me go to the down completely, and it gave me a lot of information. Oh my god, this is crazy. Okay, I don't have the time to read through all these things, so I'm just going to skip it out over here. Okay, so that is all about how you integrate your MCP servers with Cline or any kind of coding assistant or chatbot that you have. Okay, now I'm going to just minimize that window. The last thing that I want to talk about is how you integrate the MCP server in your agent itself. So if you remember, this is the agent that we had created, and its name is the incident agent, right? And just to give an overview about this agent, we have been developing this since the past 2-3 videos. So this agent takes a customer complaint as an input. It categorizes as P1, P2, P3, P4. Here is the instructions for the particular categorization that the LLM will use to categorize the particular incident or the problem that is coming through, right? And we added two tools over here. Once the categorization is done, it will send an email SNS notification. So we used AWS SNS to send the email notification to the particular stakeholders, and also to store the incident in the database in DynamoDB. Okay, so now what I did is I also added integration with the OpenAI MCP server. I wanted to create my own MCP server, but I didn't get what to do with that MCP server. Just to create an MCP server just for hello MCP server, or some kind of a get the latest time MCP server. That doesn't make sense, right? It should be something, and it's not a rocket science to create MCP server. You can use any kind of a, Chatgpt or something to get the code and create the MCP server. The important thing is to understand the concept, how the agent communicates with the MCP server. And to add it is pretty simple. The main thing that you need to understand is, I added it here. Okay, so if you see, this is the libraries that you need to use: MCP server streamable HTTP. Okay, and yeah, before that, what you need to do is you need to do some stuffs. Okay, to support MCP servers, you have to use Python, which is greater than 3.10. So I had to install Python 3.11. I installed that, and then I created my virtual environment and installed the dependencies. Okay, simple. Source your env and then install it. It is very important because I faced some issues because my previous Python version was 3.9, so it was not supporting MCP servers. So I had to upgrade it to 3.11, and then it started supporting MCP servers. And the particular thing that you need, library that you need to talk to MCP servers, is basically you can use the MCP from PydanticAI, and it should be able to, able to work. Okay, this is the thing. Okay, this is the URL. Okay, of the MCP server. So you can basically, this is nothing but the code to, if there is an environment variable exported for the OpenAI docs MCP server, it will take it from here. Otherwise, it will resolve to the default one that I have provided over here, which is the MCP server for OpenAI. Okay, so that's all the code you need to put. Okay, OpenAI docs server. Okay, you can specify the timeout and retries. This is the place. Okay, I have also defined a function over here which will basically help calling the MCP server. That's it. And then if you go back over here, I have specified in the particular prompt saying that use the OpenAI docs MCP tools to look up relevant information, call the search once with the, so if you see search OpenAI docs tools was there, so it will be able to identify, okay, that is what the tool I need to call. If results exit, call fetch once for the most relevant result ID, and if the MCP calls fails or returns no relevant result, treat it as OpenAI docs unavailable or something like that. This is just the prompts that I've put, right? Yeah, that is how why the agent is intelligent, right? You don't have to write the code to actually call the MCP tool. You just define the MCP tool like I showed in the code, and automatically the agent is intelligent enough to determine, okay, at this point of time I need to do the MCP tool call. So I'll just show you quickly. So this is the agent call. So I'm just going to go to this place over here. Okay, so this is the text. Okay, so I'm just going to call the agent. Okay, obviously it is a asynchronous agent, so I'm just going to take the task ID and then poll it, right? Pretty simple to understand. We're just going to poll this guy by giving the task ID. So by the task ID, it will be able to fetch the particular job that is running, in the background. So it says the job is completed. Okay, let's go back over here and see. So if you see over here, it called MCP tool search OpenAI docs. Okay, that is the tool that we found. When we did the list tool, there were a couple of tools over there. One of them was search OpenAI docs, and it was able to call the search OpenAI docs. Then it stored the incident in the DynamoDB table incident table, and it sent a SNS email notification. These two things we have already verified in the previous video, I guess. You can go and have a look, and you can see that it called a search OpenAI docs. So obviously, the problem that I had sent to the agent, it might not have found relevant information in the OpenAI docs. So it just returns a very small rationale saying that MCP tools were called, but I guess there was no relevant information, so it is not appending it to the particular summary. But here it is proved that it is calling the MCP server, right? So you can use any kind of MCP server that is there and integrate it with your agent. Now the MCP servers don't have to be just fetching information. If you want to create a resource as well, you can create a wrapper around a post call API, for example, that you already have, and then build the MCP server around it. So the agent will call the MCP server, which will in turn call that particular API, which will create something. So Anything that you want, you can wrap around the MCP server. Okay, so that was all about this video, guys. I just wanted to show you how you can test and integrate MCP server easily into Claude, Cline, whatever you call it, right? The coding assistant, Codex, Amazon Q, whichever you like it, and how to integrate it with your agent as well. Okay, so we're going to keep on exploring more and more on Gen AI and all of these AI tools known as the multi-agent architecture. So we have built a first agent, right? And it can use tools, connect to MCP servers, and do a lot of cool stuff. But in the real world, one agent isn't enough, because imagine, for example, you are running a, very early startup kind of a thing. Okay, you did everything yourself, for example, marketing, sales, coding, support. But as things grew, right, you hired some people, right? That's how a company grows. A designer, a developer, a marketing person, what and all, right? So each person is good at a particular thing, and then you became the manager or the CEO of that company. And this is what exactly the multi-agent architecture is. So instead of building one person or one super agent who is basically the jack of all trades but is a master of none, basically, but you build a team of specialized agents that collaborate to solve complex problems. Okay, and in this video we are going to break down these things completely. I'll cover what multi-agent architecture is, the key patterns, okay, that multi-agent architecture uses, like the orchestrator worker, sequential pipelines, and hierarchical delegation. These are all concepts of multi-agent architecture, on what principle these particular things work. So I'm gonna discuss these key patterns as well. What sub agents are, real world use cases which you can take and just code it out in Claude Code or Codex, right? Just right away. I'm going to give you all those things. And basically, I'm going to also give you a kind of hands-on walkthrough as well on this multi-agent architecture. Okay, I will show you a very simple example of a multi-agent agent, basically. An orchestrator agent, there will be an orchestrator agent, and there will be some sub agents which will basically do the work and report back to the boss agent or the orchestrator agent. Okay, now moving forward, why do single agents break down? I'm not talking about single people here because they also break down, by the way. That's a very bad joke in any ways, but yeah, why do single agents break down? Before we jump into this multi-agent architecture, let me tell you why these things happen. So let's say you build a customer support agent, right? It needs to understand the customer problem, for example, then look into the account details, check the order status, because on the other hand, the customer is shouting, and the agent has to understand everything and do all of these things, search the knowledge base, draft a response, and maybe if required, escalate it to a human customer service agent, basically. Now, if you stuff all of this into one agent, one massive system prompt you make, 15 to 20 tools, and a complex routing logic, what happens? These things happen, which you can see on my screen right here. Prompt degradation, tool confusion. Basically, performance drop when your the prompt is very complicated and there are so many steps involved that the agent gets confused, basically. Tool confusion, if you have like 20-25 tools, obviously the agent is intelligent enough to pick the particular tool based on your system prompt, for example. But if you have 15 to 20 occurrences of different tools, right, it might get confused. Now in that case, you have to upgrade your LLM, the brain of the basically the agent, to a higher LLM model. For example, you are using 4.0 mini, right, which is very less on cost, right? It's like pennies you are paying, but now your agent has become so complicated that you have to, for example, upgrade it to 5.1 or something, which is basically more money you would be paying just to make that complicated procedure make more understandable for that particular agent. And even though you are keeping now a single agent, you are paying more for the LLM. So why do you want to pay more when you can create a team of agents or sub agents. That's my point. Now, lack of distinct roles also results in inefficiency. It increases the processing time of that agent, right? Because it has to do all the tasks in a sequential fashion. But imagine it had a whole team of agents like sub agents. So the orchestrator agent or the boss agent will delegate the particular problems to its sub agents, and one by one these agents will act, in a parallel manner. And once one of the agents finishes its work, it will give the response back to the main agent basically, and the main agent will consolidate all of these things and return the response back. It is much faster. So that is the problem with one agent, which this multi-agent architecture solves, right? So let's talk about the multi-agent architecture. So as I have talked about it a little bit now, multi-agent architecture involves specialized agents that collaborate effectively to tackle complex tasks, as I've just told you. Each agent has a focused role, okay? So it does one thing well. Each agent has its own set of tools, only what it needs. Not one agent having, for example, 20 or 30 different tools, but each particular specialized agent has its own set of tools that it needs. Every sub-agent has its own instructions and optimally its own LLM. For example, you can use a higher model LLM like GPT-5 for heavy reasoning agents, and a cheaper model like 4o Mini or 4o Lite or Gemini Flash model for some sub agents which do very simple tasks, right? So you are kind of using specific, you are also choosing the brains on which these agents are going to run. You are not dependent on a single brain, right? So this is what a multi-agent architecture main idea is. Now let's walk through the main patterns on which the multi-agent architecture actually works. So orchestrator worker pattern, this is one of the most popular patterns that people or companies use nowadays. So basically, I've talked about it in a while before, right? You have one boss agent, the orchestrator. It receives the user's request, breaks it down into subtasks, right? And then delegates each subtask to a specialized worker agent. The workers do their thing and then sends the result back to the orchestrator, which basically synthesizes the final answer, right? So for example, the orchestrator thinks, okay, I need flights, hotels, and an itinerary. So I'm also planning on a particular trip now. So I thought of this use case, right? So the orchestrator thinks, for example, you're creating a multi-agent architecture for your trip, for example, Paris or something, right? So the orchestrator agent can think of, I need flights, hotels, and itinerary. So it sends task 1 to a flight search agent. You have one sub agent known as flight search agent. Task 2 to a hotel search agent. Task 3 to an itinerary planning agent. Now each worker comes back into their piece, with their piece basically. The orchestrator combines them into a beautiful travel plan and it gives it back to the user. Why is this powerful? Basically, because the workers can run in parallel. They work in parallel, right? So the flight agent doesn't need to wait for the hotel agent, and each worker has a tiny focused prompt, right? And it follows it perfectly. It doesn't have to depend on one whole sequential pattern to finish, and then the hotel agent basically needs to be invoked. The hotel agent can work in parallel, the flight agent might work in parallel, and all of these things, right? Now let's talk about the second pipelines, the pattern known as the sequential pattern. Yeah, we talked about parallel agents and it sounds cool, right? But sometimes tasks have dependencies. So for example, agent B needs the output of agent A. For example, document processing. Okay, that's a very simple example to take. So there is a parser agent it has, okay, and it takes raw PDF, extracts the data, and then there is an extractor agent which basically pulls out structured data example name, dates, amounts and all that. And then we have summarizer agent, creates a final summary. Now the thing is, one agent cannot perform an action without the completion of a previous agent. Now this is a sequential problem. Okay, now we have to be a little bit logical thinking whenever we are creating our agents, because your parallel agents are good. Orchestrator pattern is very good. It has its own needs, and basically I like the pattern, or it's one of the best patterns for me, my favorite pattern. But yeah, sequential pattern is also very important when you have these kind of dependencies, right? So basically, each agent passes its output to the next agent, basically, and like a assembly line in a factory, right? And Google's ADK, okay, they call this like the sequential agent pattern. So when to use this? Anytime your workflow has a clear pipeline like data processing, content creation with review, multi-step analysis is needed, right? Or a pipeline or something like that, you will use this kind of a pattern. Okay. Now, let's go to the pattern number 3, hierarchical sub-agent structure. Now, I don't know why I am having problems every time, spelling this hierarchical. I have some kind of lisps or something, I don't know, but this happens. And give me one moment, let me sip my coffee. It's good. Anyways, so we're talking about this hierarchical pattern, and this is where it really gets interesting. Okay, so in this pattern, agent can spawn other agents. It is pretty interesting, right? That one agent is able to spawn another agent. Okay, let me fix this slide and get the draw pen out so I can draw something. Okay, so hierarchical pattern, agents can spawn other agent. What does this mean? So basically you have a top level agent. Okay, a top level agent delegates to mid level agents, and those mid level agents can further delegate to their own sub agents. It's like a tree structure. So if you see on the screen, there is a central node. So it represents the main agent coordinating this task. So basically just think of it like this. This guy is the main agent. Then there are sub agents, specialized agents handling specific tasks effectively, but it comes in tiers. So let's talk about an example and you will understand it better. For example, there is an enterprise customer support example. Let's take that. So this will be a tier 1 agent. Tier 1 agent. So it classifies. So let's call it a router agent. It classifies, is this a billing, technical or an account problem that it has occurred, right? Next comes building agent. Sorry, not building, billing agent. So for example, it has classified, okay, this is a billing problem, then I have to route this particular topic to the billing agent. So it routes the topic to the billing agent. So it kind of visualize it like a decision tree, guys. If you know about the decision tree algorithm in machine learning, okay, or in data structures, you would understand that, okay, this is a decision tree kind of a pattern that they have derived, this hierarchical pattern sub-agent architecture. Okay, now if this is a billing agent, handles billing queries, but if it is a refund, now in this billing again, it might be a refund. Now it can delegate that work to a refund agent, basically, right? Okay, now for example, the router, now let's go back first. Now it had previously, there was one problem which it has classified as a billing problem, and then it was a refund problem. So it came in this hierarchical manner to the refund agent, right? Now for example, the problem is not related to billing, it's a technical problem. So in that case, it will route that particular problem to a technical agent. Okay, now inside, this technical agent also handles tech issues, right? But if it is a bug report, for example, it will handle that, or it will delegate that again to the lower down, and it will give it back to the bug agent, for example. So see how this is coming like a tree structure, like a hierarchical pattern. Now it is a combination of sequential and orchestrator flow. Now this technical agent is working irrespective of the output of the billing agent. Doesn't matter if this billing agent has finished or not. It can work on one technical and one billing agent, billing issue at the same time, right? It's working in parallel, right? But this refund agent cannot work without the finishing of the billing agent, basically, right? Because unless we classify it if this billing problem is refund problem or not, this refund agent will not work. So here you can think that it is kind of like a sequential pattern following. So if you combine everything, you will get a new use case, basically. And this is a very nice use case, hierarchical sub agent structure. Just imagine it like a tree structure, decision tree model, and based on that, the agent, one-on-one agent, whatever you have defined, it will get invoked, right? And will go top to bottom in this fashion. Okay. Now let's talk about a little bit more about this something known as sub agent. Okay, let me make the distinction really clear, okay, because people confuse this a lot. Multi-agent means multiple agent exist in your system. Sub-agent means an agent that is called by another agent as part of its tool execution. Multi-agent, see, you can say that sub-agents come inside the greater Venn diagram of multi-agent, but multi-agent is not equals to sub-agent. Multi-agent is not equals to sub-agent, right? But both of this come in the bigger Venn diagram of multi-agents. Okay, that is the the thing under which they are coming, but they are not basically equal to each other, right? So it's like saying that a dog is a mammal and an elephant is also a mammal, but a dog is not equals to an elephant, right? Both are mammals, but they are not equal to each other. A dog is not an elephant. That's what I'm trying to say. So you have to have a clear distinguishing idea that when an agent is called by another agent as part of its tool execution, if you remember, I will show you in a code also. I had showed in the code when we were talking about how to use tools in agents. So basically you have to use it at the rate tool execution or something in Python, PydanticAI, then it will be classified as a tool. So when you specify in your prompt, okay, call this tool, it will invoke that tool. Now, if you want to call another agent as part of, by another agent, it is the same process. An agent will not understand that, okay, I have to call one more agent. It will understand I will call one more tool. Now, inside that tool block, you can call the other sub agent. I will show you. It might be confusing a little bit, but I will show you. So, as I've told in PydanticAI, I gave you an example. A sub agent is literally invoked inside a tool function of a parent agent. That's what I'm trying to say. The parent agent decides when you want to call the sub agent. It's the same concept of calling tools, guys. Okay. So what input to give, how to use its output, the sub agent doesn't even know the end user exists. It's just is a tool kind of execution. Once the tool is executed, it returns back the output. The agent which called that particular sub agent receives that output and it does its job. The sub agent is just independent, doesn't know who called me or whatever. I just have to do my work and give it. So it's like a frustrated employee in your company, right? He just does its work and throws the work at its boss. It doesn't matter what will the boss do, burn it or do whatever he wants, right? So that is what the sub agents do, right? So here is the mental model that I want you guys to understand. Think of it like, for example, in a law firm, or the example I gave you, just like an employee example. The senior partner, the parent agent, meets the client. Let's make it a story, okay? The senior partner, if you have watched Suits, the series, I love it very much. You will have an idea about senior partners and junior partners and interns or whatever, but you can relate it to other hierarchical structures as well. So the senior partner meets the client, for example. The client says, okay, I need help with a contract dispute. The senior partner doesn't do everything. It delegates. So for example, there is a paralegal, consider it as a sub-agent. The senior partner delegates it to do some research, to the junior associate, that's another sub-agent, it delegates to draft some initial documents. To the, for example, the financial analyst, okay, think of it another sub-agent, to assess the damages, basically. Now these three guys, the client never talks to these people. These people only the senior partner, deals with, right? The client never talks to these people directly. They only interact with the senior partner who they have actually approached to. That person is the orchestrator of all of these sub agents. That senior partner knows whom to call at what time, basically. Let me sip on my coffee again. It's really amazing. I can't resist it. Good. It takes a lot of toll to talk constantly in so much time, so you need some refreshments in the middle. Anyways, so this is what I wanted guys to understand. Basically, it is better if I show you in code, right? It is better to show how in Pydantic AI, basically the tools, inside the tools you call an agent. So I have created a simple code over here. I don't even need to run it, or I have already shown you how to run a particular agent and all. You can just try this out. I just want to show how the particular structure, how you actually call a sub agent. So this code I have generated using Claude code. Okay, why would I take there is no point in writing code. So you can just give an example to Claude code, plan it out, and basically then execute that plan. All these steps I have explained it in my Claude code masterclass. You can go and have a look. So this is a sub agent called a research agent. Okay, I have done the agent definition over here. Okay, so I have also passed in the instruction, research the given topic thoroughly, return a list of 5 to 7 key facts and insights that will be valuable for the target audience. Now this is the parent agent, the writer agent. So basically based on the research that the writer gets, right, then the writer will write some article or write its book or something like that, right? Now see, in the writer agent, these are just nothing but the LLM models. Okay, you can replace it with whatever you want. Okay, so if you see the instruction, you are an expert content writer, use the research tool to gather information, then write a compelling article. Now if you see the research tool, do research, that you see over here, inside this tool I am calling the research agent, okay, which I have defined over here. I'm calling the research agent which I have defined over there, and then the research agent runs and returns the output. That's it. It is not communicating or returning the final output. So once the writer agent gets the output from the research agent via this tool, do research, okay, via this tool called do research, then it returns back the output, and then this writer agent will take that output, and finally that writer agent will print the output. For now I'm just printing the output. You can do whatever you want. If you have an API or something, you can integrate it. You can integrate agents in any way you want. Okay, so that's it. That's how in Pydantic AI you would call, for example, the sub agent. Basically inside a tool, you wrap that sub agent inside a tool and call it as part of the tool execution itself, not like a different agent call or like a different rocket science you are doing. That is not how it works. Okay, it's very simple. Treat the sub agent as a tool, call the sub agent as part of the tool execution. That's it. Okay, that's I wanted to understand, just give you a small hands-on knowledge about multi-agents, so you will understand how this works. Okay, and the code is pretty simple, guys. You can just run it in Claude code or Codex or whatever. Your free versions will also work. Not a very complicated problem. You can just work it out. You'll also get a lot of examples, and I'll also share this code as part of this video as well, so you can just copy paste and run the code. So now let's talk about some real world use cases that you can take and actually implement in your multi-agent architecture. So first is AI content pipeline, right? So just I discussed about the research agent, right? So you would have you want to automate this block content creation. So you can create like your own agent team. You can create all of these multiple agents. Like the research agent uses web search tools to gather information on a topic. Then we have an outline agent, who is responsible for organizing ideas into structured formats. Then we have a writing agent, writes the full article based on the outline. Then an editor agent, for example, you have add one more agent. Reviews for grammar, grammar, tone, factual accuracy, all of these stuffs, right? And then the SEO agent. SEO agent is very important, guys, because it will optimize your headings, meta description, keyword density, and basically your article will come on the top of your, search results basically. Now this is a sequential pipeline problem. So first the research agent, it will give the output back to the outline agent, then it will give the output back to the writing agent, then the editing agent. Finally, once while posting the particular article, the SEO agent will come into the picture. I hope that is making sense. Next, smart customer support. This I have already given an example, about, while I was explaining. So I already gave you the router agent, billing agent, technical agent, escalation agent. For example, you create one more agent called as escalation agent. When none of this billing agent or technical agent is able to handle it, it will again go down in the hierarchical, tree to the escalation agent, for example. So it will prepare a summary for human handoff. It will give the escalated whatever, the information it's got from the upper agent. For example, the technical agent, let me again select the writing thing over here, right? So the escalation agent, it will gather all of the information that it got from the billing agent, the technical agent, and all those kind of agent. It will prepare a summary and send a mail, for example, mail to stakeholders. Now from here the human interaction might begin, the developers and all those things. So yeah, that was an example. I had explained it just previously as part of the hierarchical, multi-agent architecture, and this is also an example of hierarchical, multi-agent architecture. Smart customer support, you can design it on yourself as well. Deep research system. Okay, now this is exactly what Anthropic built for Claude's research feature, and here is the architecture. Okay, so there is a lead agent called the orchestrator. It receives the query, creates a research plan, spawns sub agents, and this is also a part of this Claude's certification exam. You might get some questions as well. So there is a Claude's research feature. Okay, about Claude's research feature, basically like deep research of Chatgpt, we have the Claude's research feature. Okay, you can use that for deep research. So here it's like a orchestrator pattern only. You will have a lead agent. Basically it basically receives the query of the user, what it wants the research on, creates a research plan, and spawns sub agents. Now these are known as search sub agents. Okay, so each one researches a different angle in parallel. For example, you are researching on, for example, stem cells. Now there are a lot of research papers on stem cells. There will be it will spawn a lot of sub agents. One agent will plan research in one particular research paper or one particular article or something like that in parallel. And then we have a synthesis agent, combines all of the findings of various search sub agents, and then the lead agent is smart about taking that particular thing and returning it back in a very beautiful manner, for example as a MD file or as a PDF or whatever the user has requested. Now this lead agent is smart about delegation. It doesn't say research AI. It says sub agent 1, research the history of stem cells. Sub agent 2, find the latest papers on the efficiency improvements of stem cells. Like sub agent 3, for example, look into commercial applications or commercial findings of stem cells, something like that. Now the lead agent is the orchestrator, and these are all the sub agents. So orchestrator pattern it has followed over here. Fourth, very important, we can say one more example we can discuss about is known as the, for example, you are designing, you're working in a technical company. I think I forgot the slide over here for the code review use case, but I'll just tell it out. So for example, you have a code review system you have developed. You can have multiple agents for that as well. You can have a code analyzer agent, then a security audit agent, then a performance test agent, then a style, the check style, all those things, coding standards, all those things, check style agent, for example. And then you have a report generator agent. So it will combine all of the findings of these agents, and then it will generate the report in for structured review. Code review agent, you can think of it. It's pretty simple to understand. Okay. Now, I guess we are kind of done. So some of the best practices I want to discuss is, first thing I want to discuss about simplicity. Start with the basic structures. Don't directly give to Claude code that, do all this agent, create 100 agents. Don't do that. Start with a very simple agent. As you find out more use cases, enhance on that agent and create more sub agents. Boundaries. Establish clear boundaries to avoid confusion and overlap. It is very, very important, guys, because one agent should not do the work of another agent. There should be a clear boundary of what one particular agent is doing. And then observability. Ensure, you see, the thing about agents is that if you create multiple or a very lot of agents, right, you will not be able to track the it will be difficult to track the token usage as well each agent is using. Sometimes if one of the agents starts hallucinating, it can take the billing up to a whole level, because it will consume a lot of more tokens. So you can monitor, you can pass on context around each of these agents, right, so that they can the context around the agents also gets added up, and the orchestrator agent also gets kind of how much context these agents have used in total. And it can also give you a billing overview as well of how much cost is there by running all these agents. You don't have to do it manually as well. One more agent you can create, like the cost agent, for example. It will keep an eye on all of these agents. If there is a particular threshold that you have set for the tokens and all, input output tokens, it can see that. For example, it can review that and send you an email or a particular alert or something like that, like an alerting agent you can have. So you have to have proper observability as well. It's very easy to create. You can go to Claude, for example. You have a system, you can go to Claude to just create an observability dashboard, right, where the alert agent will push the data to the observability dashboard. It is nothing not that hard to create nowadays, that we have Claude Code and Codex and all of these things. You can try that out as well. If you want me to create one more video on how to create how to basically observability on agents, how do you track the usage metrics of the agents, I will create one more video. You can just put it down in the comments if you need it. Okay, so just to talk about collaboration is the key to success. So please make use of all of these agentic features, multi-agent architecture, and whatever you need as per your use case. We keep on exploring our knowledge about Gen AI and agents. Today I'm going to cover a little bit different about agents, right? So previously we had created code-based agents, right, where we actually coded the agent using Pydantic AI, and then we were able to use some tools. Then we explored about MCP servers, and then we integrated the MCP server with our agent as well. So that was on a very low level where you have full control over the agent. You know what your agent is doing. You are actually the creator of the agent. But now let us come to a form of agent. Let us learn a form of agent which is kind of a software as a service, like a SaaS offering, or as a PaaS offering, right? Platform as a service. So we are going to talk about Chatgpt agents, right? Now this is a different form of agents which I really like. Okay, so this is a kind of agent where you just go and click on a button and the agent will start working. You don't have to code anything. You don't have to deploy your agent. You don't have to worry about anything. But the one downside to this kind of agent is that you don't have complete control over the agent. Okay. Yes, you can, ChatGPT now allows to integrate a lot of tools that the agent can use, right? But still you don't have complete control. So keep that in mind while you are learning about it. But yeah, when it comes to your day-to-day activities, for example, you want to build a personal assistant or something like that, I'll show you that demo in a minute. So if you have that kind of use cases, then this is perfect, right? Just to automate your boring tasks that you do in day-to-day life or something like that, it is the best thing that you would get. Also, you cannot ship this agent for a customer or something like that. If you want to do that kind of a integration, then you would have to go with code based agents that I showed previously, right? You can watch out the video about that. So yeah, as I've told you, this agent also, the ChatGPT agents also work with tools. It will obviously it is powered by ChatGPT, so we have the GPT models powering its brain and all those things, right? But yeah, you don't have complete control over it. That's what it is, right? And it will execute in its own environment. It will show you what it is actually doing. For example, it is installing some software, it is searching the web or all those things. It will show you what it is doing, but you cannot like go and stop it or interfere or do some code changes for that particular agent. It is not possible. Okay, it is platform kind of an agent. Okay, so let us pick a use case. I'm going to show you two use cases in this particular kind of a demo session, okay, for ChatGPT agents. The first use case that I'm going to show you is building a personal assistant using ChatGPT agent. Obviously, we are going to use a prompt to power up the agent. We are going to tell what the agent needs to do. So in this personal assistant agent, what I'm going to ask the agent to do is basically review my calendar for the current week and build a weekly life dashboard. So it's kind of like it will act like my personal assistant, right? Now, for now, I'm going to keep it simple, just to review the calendar and pick out something, just review my life that is going to happen in the coming week or this week, right? Summarize my meetings and commitment day by day, identify the busiest day and the lightest day, highlight my back-to-back meeting overload, identify available focus blocks. So I've just put down some points, which a general personal assistant would do, right? Give me 3 practical suggestions to improve next week and present the result as a clean dashboard with these sections: week at a glance, meeting by day, overload signals, focus opportunities, and recommendations. Okay. Now, if you are integrating more tools like send emails or something like that, that also you can use it as a tool. The agent can do all those stuff. You just have to give access to those tools for that agent. I'm going to show you in a minute. Okay. So before we start copy pasting this particular prompt into the particular agent, which is basically ChatGPT itself, I'm going to just talk about a few things. First of all, to use the agent, you have to select the agent mode. Okay, so you have to click on this plus button over here and then click on mode. Okay, and then select agent mode. Now, if you see, if I try to type something and if I try to execute it, now this button is grayed out. The reason it is grayed out is that an agent needs some tools to work with. Currently, there is no tool. If there is no tool, doesn't make any sense to actually use an agent, because the normal chat will also work. If you want to search for something, you want to converse with the ChatGPT agent, it is okay. You can directly use it on the chat. Agent comes in the picture when it has to work with tools, right? The LLM is the brain of the agent and the tools are the hands and legs of the agent, which the agent will use. Okay, so keep that in mind. I've already explained this in the previous videos. So I need the agent to review my calendar, right? So I have to link ChatGPT with my calendar. So how to do that? Currently it supports, I think, Outlook and Google calendars. Okay, so if you I have already connected my calendar. Nothing, you just have to click on connect more over here. Okay, and click on add more. If you have already not done it, you can add apps over here, right? For example, if I search for calendar, you see Google Calendar is over here and it is already connected, right? Otherwise, it will show an option to connect it. Okay, you can disconnect it and reconnect it as well. Pretty simple, just a user thing over here. I'm just gonna go back. Okay, I'm just gonna open this up and click on a new chat. Okay, I'm just gonna click it. Now I've shown you how you need to connect your application so it can be used as tools by the agent, right? So I've already connected my Google Calendar to that. So I'm just gonna go over here and go to agent mode and click on apps and enable the Google Calendar tool over here, right? So now if you see over here, I'm going to now use this agent to do some work, I mean interact with my calendar, right? So I'm just gonna copy paste this prompt from here, right? So I'm just gonna take this out and paste it over here like this. Okay, so this is my prompt. So now it will work as agent mode over here because I have put the tool as that. And now if you see the particular button is not grayed out because I'm using a tool over here which is basically calendar tool. So I'm telling, you know, this is my prompt and this is what I want my agent to do. Now I'm gonna just so yeah, before I actually okay, use agent mode with connectors. So it is just giving me a warning. Choose connectors with care. Using only the connectors needed for a task helps reduce privacy risk. Okay, it is giving me a warning. So it is telling me that use your connectors responsibly. So I have connected calendar over here. So you have to be specific about what tools you need to use. Okay, you want to give too much access to the agent because you know it is working in the background. If something happens, you are the person who is responsible. Okay, so make sure whatever connector, whatever apps you are connected to in the Chatgpt, you are well accounted for. Okay, so I'm just going to show you my calendar. This is just a basic calendar that I have created. You know, I've just created 4 days with some blockers over here. Okay, some random blockers so that the agent has something to work with. Okay, so I'm just let me go over here and let me check the prompt once. Okay, review my calendar for the current week. I thought I have put next week. Okay, so now let me execute this and I understand. Okay, now it will work on agent mode. So it is working. Now I'm going to show you a little bit about here. So it is showing what it is doing over here, you know. So as I told you, right, these agents will show you what they are doing on the screen. Even though you don't have control over this agent, it is telling that okay, now currently it is calling the search events API and then it is attempting to call the Google Calendar API, right? And it will do some tasks over here. Okay, let us click on continue. Okay, so it is doing the stuffs over here. So I'm going to pause the video for now and maybe sign in. Okay, it is asking me to log in. So let me just log back in and then start the agent again. I did some digging and I found out that what is happening over here is even though your Google Calendar app is connected over here, right? I mean, I showed you like right where if you want to add the connection, it's still there, right? If you go to apps over here and if you search for calendar, you see everything is fine, it is connected and all, but still that particular agent was not able to access it, right? So if you see what I did over here is basically instead of using the agent directly, because I think in the agent environment itself, it is not able to figure out, okay, this is the connected app over here, and it is kind of creating a new session. So the login which I did over here, right, it is getting lost in the agent environment, right? But if I use it normally, so normally you can just directly go over here and you can go to more, right, in the chat, and you can just click on the Google Calendar and it will pick up that connector and it will work like whatever you wanted. So I told review my calendar for the current week and build a weekly live dashboard, and I gave all of these options. So it is correctly fetching it from my calendar. It is saying week at a glance. Your calendar for the current week, March 16 to 22, 26, is heavily concentrated from Wednesday to Saturday, obviously, because if you see Wednesday, Thursday, Friday, Saturday, I have put on some blockers over here and it is correctly reading it, right? It is correctly reading it and it is telling, okay, meeting with stakeholders and work on project. If I click over here, it should take me to my calendar link, right? It is also working over here. but somehow through the agent it was not working. I'm not sure why. It might be a bug over there, but yeah, it is working in the normal chat. Okay, that was my expectation, so it is working, so it is fine. But I wanted to show the agent in action. It tried to log in, but it was not able to, basically because of the session, or it is creating, it is trying to open its own browser and trying to log in, but it is not finding that connector over there, which we logged in over here, right, in our current browser. So it is, but anyways, it is getting the meetings in the normal chat. I have connected the Google Calendar. Tuesday, March 17th, there is no visible events because today is Tuesday. It's almost night. Obviously, there are no visible events. So, but it is telling Wednesday, Thursday, Friday, and Saturday, there are back-to-back meetings. And it is telling that there are overload signals, 4 consecutive overloaded days, near back-to-back scheduling. You only have 30 minutes between 1:30 p.m. to 2 p.m. on each of the 4 busy days. That is not enough buffer for lunch, spillover, decompression, context switching, whatever it is telling, right? Very long continuous work days, fragmentation inside a different pattern. It is just giving me some suggestions based on my prompt, right? Now you can connect more apps also. So if you go and select calendar and Gmail, you can work with both in the normal chat, but I'm not sure why it is not working with the agent, right? But since I wanted to show you the agent in action, the Chatgpt agent in action, I'm going to try out one more prompt and see if I'm able to use the agent, right? But still, if you want to use the connector apps directly, you can use it in the chat. So I'm going to go over to my prompt section again, and I have one more prompt for a personal job applicator. It's a very interesting thing because we spend a lot of time digging through like 10 different job portals and evaluating our resume in 10 different places, and we end up getting frustrated when we don't get a matching job or something like that, right? And it really pisses people off. So what I have done is, using the agent, what we are going to do is, I've just designed a prompt over here where I'm telling I'm applying for the senior front-end engineer role at Razorpay. Just like example company, you can choose any company over there. And I have a resume, I have a sample resume. I'm telling I have uploaded my resume. Please do the following. And these are the points. Search for the web and research Razorpay, their engineering culture, tech stack, recent news, funding, and what they look for in engineers, and any recent product launches. So I'm kind of like training my agent to do this thing, right? Like a personal job applicator thing. Read my uploaded resume carefully. Rewrite my resume bullet points to better match this role at Razorpay. Obviously, use keywords from the job description, highlight relevant experience, and make it ATS friendly. Write me a personalized cover letter for this specific role and company and make it sound human. Reference something specific about Razorpay and connect my experience to what they actually need. Give me 10 likely interview questions for this role at Razorpay with suggested answers based on my resume and experience, and organize all of this clearly in one document. So a lot of things I'm telling this agent to do. I'm not asking it to interact with Gmail or calendar or something like that, because the agent might mess up and it will not be able to interact with it. So I'm just giving it general instructions to kind of make my job application easier, right? Kind of frame it in a way so that it matches the job description at Razorpay. Okay, so I'm just gonna copy this particular prompt from here, go back and paste it here, and I'm gonna select the agent mode. Okay, I also need to kind of upload the resume. So I'm just gonna, this is the resume that I've created. Okay, Arjun Mehta resume.docs. It's a sample resume. If you want, you can check this out, but yeah, let's not waste time checking the resume. Okay, so this is the thing. I hope the agent will work. Okay, this button is grayed out for some reason. Okay, this is rather very weird. It is not letting me execute the agent directly, maybe because it needs some tools that you need to use, but here I just need maybe the web browser tool, right? But it's not there over here. It's only if I try to use the Cloud browser, it's not making me to switch on the toggle. So just to make the agent work, I need to select some kind of a tool. Okay, and it's weird, I'm not able to use it. That's why I told, you know, sometimes you don't have complete control over this agent, and it is a little bit of a downside. But yeah, I need to make the agent work, so I'll just select some random tool. I'm just gonna select Gmail over here, but I haven't mentioned that I need to interact with Gmail, so it will not use it, and it will use this particular uploaded um, resume from here. But I am kind of thinking that if I don't actually provide this resume, it might try to log in into my Gmail and search for some resume, and it will fail over there also, I think, because it was not able to access my calendar as well, right? It's kind of a little bit of a thing that is happening over here. But let's see if it is able to read this resume and it is able to perform all of these activities that I just told. Okay, so it's agent mode. Let's execute this. Let's see what this agent is trying to do. Let's see. It's setting up the desktop. Okay, I think it was able to access my, okay, it was able to access my resume. But I think they should not force us to use a tool which, when we don't want to use a tool, right? It is frustrating. Why do we have to select a tool when we don't have to use it, right? They can just make the web browser tool or something like that by default, like a default tool kind of a thing for the agent, so that we don't have to explicitly select a tool when we don't need it, right? I hope you guys understand what I'm telling. So it is kind of like not using the Gmail tool, but it anyways I have enabled it because I wanted to use the agent. So it is kind of attempting to open local doc. Okay, it is trying to open up my thing. Okay, I'm going to pause this video and I'm going to kind of resume it once this particular agent thing is done. Resume the video so that I'm going to show you some interesting thing that this agent is doing over here. If you see, it is opening its desktop and it is reading the resume over here, and it is kind of it is created the Razorpay report file or something like that, and it has finished. It is everything it is doing in the terminal. It looks cool over here. So this is the agent execution. Basically, you will be able to see it live what it is doing. Okay. So this is what it prepared. So application research and preparation for Razorpay senior front-end engineer role. The user has disabled web search. Why have I disabled web search? Okay, this is ridiculous. I have actually, okay, I had to enable search, but it will change it back to search the web. So if I select web search, I will not be able to use the agent mode over here. This is weird. But anyways, gonna look at that later. I feel some kind of bug is there, but we'll see. So tech stack, recent news and funding, it is trying to fetch it up, and it is saying what Razorpay looks in engineers. So it has also updated the bullet points in the resume. Okay, and personalized cover letter, it has also generated that, your hiring manager and whatever and whatnot. Okay, 10 likely interview questions and suggested answers. So it is reading from our resume and it has prepared these kind of questions. Okay, webhook monitoring UI. So it is just from our resume, because I prepared the resume. Performance of a React application ensured accessibility in your projects. Okay, so it is giving us something, right? Now agent is working. So if you see the sources, right, it is taking the sources just from the resume the agent took, but it has not actually gone to the web, and it has not used the web over here. and actually because it is saying that the user has disabled web search, so the research below is based on general knowledge up to early 2024. You cannot verify recent developments or news. If you need the latest information, please enable web access or conduct additional research. I'm not sure why it is not reading it. Maybe what I'm gonna do is I'm gonna copy up this prompt again and maybe explicitly tell that, use the web search. Let's try that, because it is enabled and it should be able to use it actually. Okay, please use the web search for up to date information. Okay, let me check. Because if I enable web search, I'm not sure if the agent mode will be there or not. Let me see if I can add more source. No, it's not letting me do that. So let's use agent mode only, and let's see if it will be able to fetch it from the web or not. Let us see if this time it kind of uses the web search or not. Okay, so it is still not able to do the web search. It is weird. So I'm gonna just so you can enable the web search like this, but I'm not able to use it with the agent. So if I directly use the web search like this and I grab my prompt from here and paste it here, probably will it also, if I just say use agent mode to do this, for example, do this task, will it use the agent mode with the web search? Let me see. Okay, I haven't actually okay, let me kind of, I forgot to upload the okay, so I'm gonna upload that resume. I kind of forgot to do that. Okay, okay, now it is searching the web, but the thing is, but it is not using the agent. That is a downfall, I would see, because I'm not able to use web search with agent, but it is doing the job and it is also doing the cover letter thing. So yeah, there are a lot of downsides in using this Chatgpt agent, I'm feeling, because even though if they are allowing it somewhere, the web search and all those tools, it is not very user friendly, I would feel, because sometimes if you are not selecting the tool, then if you are using agent mode, then it is getting grayed out. Previously, I remember the using agent mode was pretty nice because it was not that much complicated to use it over here, but now I'm not sure why all these things are happening. But I guess you guys got an idea how to use this ChatGPT agents. If you have a use case, you can try this out. One last thing to tell: this ChatGPT agents come under the don't come under the free plan. It comes under the plus and the pro subscriptions. And still there also, I guess you get about 40 to 50 agent executions per month in the plus subscription. Keep that in mind if you want to try out the agents. But to be really honest, I'm not seeing that much value in this, but just to have the information, if you have a specific use case where this agent will be beneficial, you can work it out basically. Okay, so that was all for this video, guys. I hope you guys have enjoyed this. I'm gonna come up with a lot more interesting videos, and till then, have a nice day. Take care. Bye bye. Tata.